Hello and welcome to Spindle TV. How are you guys and girls doing tonight? My name is Laney Shaughnessy. For those of you that might be new, I will be your host for this evening. And tonight, we've got a pretty interesting project that was asked of me to do a class on this project. Customer and viewer, Michael Murphy, reached out to me and said, hey, Woodsmith, they had an episode in their CNC base camp that covered the making of these three wooden arts and crafts tables. I'd love to see you make a class out of it and everything to show how to bring it into Vectric and, importing it, laying out the design, and then creating the Toolpaths, right, and the Vectric software and everything. So I went over to CNC Basecamp, their link to the episode number 14. The link to the episode with all the files and everything is down in the description of this video. So you can actually get those files and everything. They have them free for download and stuff. But I went over and watched their video, which we're going to talk about tonight. And while they did a good job on the build of the three tables and talking on some of the key points of the build and the joinery and everything, they didn't really go into a lot of detail on what to do with the files that they're providing. They provided a PDF document of their tables. Let's switch over to the screen so you can all see what's going on, and we'll go from there. But welcome everybody. Thanks everybody for hanging out with me and all that good stuff. It's always awesome to have you guys hang out with me. Sorry about last night. Yesterday, for some reason, we had no internet here in town in my area all day. Finally, around 10 p.m. last night, they finally got it working again, and all was well. But this class was supposed to happen yesterday. All right, let's switch over to camera 2. And let's get me down in the bottom left corner here. And what you can see on the screen are these three arts and crafts tables. Now, I took the time yesterday and recreated these items in SketchUp because I wanted to be able to deconstruct the parts in a 3D view in SketchUp to discuss and talk about them. I want to talk about the files that they provided. So let's pull over here on the screen the three PDFs. So when you download the files, you'll get a PDF of the round table that we're going to be talking about tonight. The inspired Limbert Cafe table, which is a really nice little table, and a hall table, kind of a nice little hall table. And so these three arts and crafts style tables, they feature things like through tenons, which are really nice. There's going to be some good joinery in here. There's shoulder cuts in the parts, and it's not all going to be CNC. It's going to be a combination to make these tables and everything. And what they did really well in the video, even though they didn't show in long detail the making of the parts, like the carving on the CNC, they highlighted some of the key details of the CNC. But some parts, like the tabletop of the hall table, they used a table saw to cut the table down to size and to do the chamfers that are on the table, and we'll discuss those more in just a moment. They used a combination of block planes to do chamfers on the edges to remove the sharp edges. They used chisels to square up the inside and outside corners of the joinery and everything, so that they didn't have to use like dog bone fillets and stuff in the software, even though they did use T-bone fillets for the joinery. We'll talk about that when we get into Vectric and stuff. But it wasn't just all CNC. It was a combination of CNC, table saw, and some hand tools, right? Now, a lot of these parts have large size panels, like the Limerick Cafe. The tabletop itself is 37 inches by 24 inches, and the side pieces, these side pieces and everything, they're about 29 inches tall and about 25. Let's see here. I would say about 25 inches wide. And they talk about, you know, if you have a smaller CNC, let's say you have, like for a digital wood carver, let's say you have the mini carver. While you can't cut the entire part on the CNC, you can use a combination of, let's say, a jigsaw or a bandsaw or a handsaw, sanding and everything to cut the contour shapes and all of the parts. Let's see if we can zoom in here for a moment. And you can see how we have this on this side piece here, how we have this kind of arched edge and everything. You can use a jigsaw to make that cut on these if these panels are too big for your CNC. But you can lay this panel on your CNC and you can let the CNC do the cuts of these inside squares and the mortises and things. And so the CNC can do some of the main key components while your hand tools or your power tools and stuff do the rest. So I really like that they involve the CNC and they explain in the video the role the CNC played for the, you know, important joinery and stuff like that. And but yet they also incorporated, you know, working with a block plane to create a chamfer on the edges. They worked with, you know, chisel to clean up the inside corners and everything for the joinery, so they didn't have to use dog bone fillets, which we're going to talk about. You don't have to do, but it sure does make the joinery look so much cleaner when those fillets can be hidden by the parts themselves when they're assembled and everything. And it really, just allows for the piece and the through tenons and things like that to really kind of speak for themselves rather than, you know, the eyesores of dog bone fillets and things like that. And T-bone fillets and all that stuff. The thing of it is, besides these three PDFs, you also receive vectors and of the parts and all. Now let me turn off the dimensions because they don't come with dimensions and everything. And I've got all the parts for all three tables laid out in one screen here. Now we are going to break this up into 3 individual projects. We're going to do one at a time and discuss them. And I'm going to be jumping back and forth between VCarve Pro and Vectric, VCarve Pro, sorry, and SketchUp and things like that. Because I want to kind of really discuss, I want to talk about some of the key things that they talk about in their video. That way when you're watching the video, because I really do encourage you to go watch episode 14 of the Basecamp. And I went through, I kind of got enthralled, and thank you, Michael Murphy, for pointing it out to me. But I actually went through and looked at some of their other Basecamp, CNC Basecamp videos, and they did a really good job. And there's a lot of metal inlays, aluminum, copper, brass, and bronze inlays into wood. And cutting those parts with the CNC, you know. So I'm looking forward to doing that class with you guys and girls. But on these tables, when the vectors files, the DXF files for, you know, the sides and the top and the lid and this and that, when they get imported in, And the PDFs, these PDFs that, you know, have some of the dimensions here, it really leaves a lot to interpretation. And when I interpret, the way I interpreted it, the way I interpreted it when I was designing the parts and redesigning them in SketchUp, I actually interpreted them wrong. The way they did the joinery and everything, I interpreted it wrong. I assumed there was dog bone fillets and they just forgot to put them in the PDF. I assumed that they forgot to add certain vectors to the PDFs that you import in, or to the vector files that you import into Vectric. I assume they forgot some of the vectors that create some of the joinery and everything, the shoulders and all. Now, one part, you know, I made that assumption because of the information that I did not have, right? The information the video didn't show, the PDF didn't show, or the vectors didn't show. So I finally watched the video, and the video kind of pulled it all together. The video, they did a great job on explaining what they did with the joinery and the fillets and things like that. They didn't show it in any type of design software or, you know, creating the Toolpaths or anything like that. They didn't show any of that. That's what I'm doing here, and that's what we're going to jump into. But they did, the instructor in the video, let's pull this over here. And in the video, when they were, let's get to some of the highlights here. Let me get to a key point. They did go through and they did explain where they used fillets and what type of fillets they used and why. And what they did in the design, the vectors themselves, to hide those fillets when everything was assembled. They went in and they did a good job at explaining of where they cleaned up the corners on the actual mortise and where they rounded over the corners on the actual tenon, depending one or the other. It wasn't both, it was one or the other, so that they didn't have to do two-sided jobs, or they didn't have to do dog bone fillets and things like that. And it really made the assembly clean. It required a little bit of hand tools. So the whole reason I'm going through this whole spiel and everything is to say that not everything can be done on the CNC. Some things do require hand tools and stuff. And I really like these three projects. Michael Murphy, thanks for bringing them to my attention. But I really like these three projects because of the fact that they did incorporate some hand tools in there. And the reason why they incorporated the hand tools in there is for the cleanliness of the assembly and that finished piece, the aesthetics, the look that this table, this arts and crafts table is supposed to have when everything is all said and done, right? It looks like it was all made by hand and assembled, where actually a majority of the parts were cut out with a CNC machine. Right? I really like that and everything. So let's pull this out of here, out of our way. And let's minimize the PDFs. And you can see that I have all the files here and everything, all the vectors imported and stuff. And I'm going to do them one by one now. So what I'm going to do is I'm going to open up a brand new window. And the first file that we'll do is we'll do the haul table. Okay, we'll talk about the haul table and everything. And with the haul table, the boards, sides and everything, they're all going to be the same. So the haul table is going to be 36 inches by 12 inches, roughly. So that's what we're going to start with. So we're going to create a new file, and we're going to go 36 by 12 by 1.125" thick. Okay. We'll talk about the thickness in just a moment. Okay, because we're going to create multiple sheets or boards, because there's going to be multiple parts for the sides, the two sides. The top doesn't necessarily have to be done on the CNC as far as the whole top, but some of the joinery does on the top. And the stretcher that stretches together on the lower side, it's a different thickness and all. We're going to talk about thicknesses in just a minute, but this first one we're going to talk about is 1.125" thick. We're going to be referencing off the material surface is fine. And I'm going to start in the bottom left corner for the XY datum position. Okay. So we're going to go ahead and click OK. And we're going to start with the importation of the file of the documents. So we're going to go up here at the top, file operations, for those of you that might be new. File operations, first row, the icon for importing vectors, because these are vector files. They're DXF, EPS, AI, that type of file. So we're going to import those in, and we're going to back up to the haul table. And on the haul table, you get the DXF file for the stretcher. You get the DXF file for the shelf stretcher, the arched stretcher, so the shelf stretcher low, the arched stretcher up high, the side piece, and the top piece. And of course, we'll double the side piece because it requires two sides, right? Now, when we're importing the vector, we can only import one at a time. It won't let me, select multiple files and things like that. So that's fine. We're going to just import the arched stretcher first. Okay. And I'm just going to move it over to the side over here. And we're going to import the shelf stretcher, okay, which is just the shelf piece. I'll move that over here. We're going to import the side. Okay, so we'll move that over here. And since I'm working with my longest length of my board along the x-axis, I'm going to go ahead and rotate the side 90 degrees. I'm going to hit the letter 0, or the number 0, not the letter 0. I'm going to hit the number 0 on the keyboard, and that's going to rotate that part in 45-degree increments. I'm going to hit it twice to rotate that. We'll drag that up there. And then the final DXF is going to be the top. Okay. And let's... Oh, work with me. All right, let's move that down here. Okay, so very simple enough, or simple enough, not very simple enough, but simple enough. These are the vectors that are only the vectors that are required for the haul table, importing them in. Now, in here, there's none of the fillets that they talk about in the video and everything, the T-bone fillets and stuff like that. And they don't really kind of, there's no instruction as far as what toolpath creates what cut. They're assuming, they're under the assumption that you can watch the video, see the joinery and everything, and with the keywords that they're using, pocket cuts or T-bone fillet and things like that, that you would be able to work those files and create those fillets and those cuts and those tool paths just from the keyword information that is kind of, spit out in the video. And that's not necessarily the case, right? And if we're going to be kind of going back and forth between the PDF and what we've imported into Vectric, okay? So on the PDF, they show us good views, isometric views and front views and side views and top views and everything of the table. so we can get a mental picture of how this thing is going to get assembled. They show us dimensions of some of the key parts and everything, and they pretty much leave it at that, right? So the vectors that we import, they are imported into the proper size, so there's no scaling or anything like that required. We just have to look at the PDF for the thickness of the boards that we're supposed to cut these parts out of. Okay? Some of the measurements, they are missing, like the arched stretcher. The arch stretchers are made out of 1 inch thick material. The top, the lid is 1 1/8 inch thick, and then the legs for the whole table are 1 inch thick materials, and the shelf stretcher is 3/4 inch thick material. Okay, so you're going to have these different boards at different thicknesses and things. You know, that's that. Right. Okay. So, let's go back to our drawing here. Now, most all of the parts are under the size of 36 by 12 here. The top is 36 by 10 5/8. In its size, the sides here are 29 3/4 in length by 11 1/2 at the widest point. The shelf stretcher is going to be 24 inches in length by 6 1/2 inches wide, and the arched stretcher, which there's going to be 2 of those as well, that is at its highest part to its lowest part is about 6 5/8 by 24 inches in length. Now, I want to show you on my other Vectric drawing that when I imported these parts and everything, let me turn the dimensions back on so you can see what all I did is I had to kind of go through, and what I always do is I never assume, I never take for granted that a drawing is 100% correct. You know, I always assume that there's going to be a problem somewhere. I only found one problem in this design, and it was in the round table. It's not this table, but I only found one problem, and it was just the placement of the mortises and things. They were just slightly off center where they were supposed to be and everything. But other than that, everything was great, right? So the point of that whole thing is I had to take measurements and everything just so that I could recreate the table in SketchUp. So let me go through and hide these 2 tables. Let's explode this one. And let me move some parts around. So we're going to move this up. We're going to move this out. And I'll leave that side connected. I just want to be able to show you the joinery and stuff and everything. Okay? I want to be able to show you, you know, everything that's going on here. Now, I had to take those measurements for all of the parts, and I had to, you know, validate each of the parts and everything so I could, you know, redraw it in SketchUp and stuff. But all of the parts, and also it helped me kind of verify that there was nothing off or wrong or anything. Like I said, I only found one mistake, and I'll show you that when we get to the round table and stuff. But other than that, everything was great, right? There just wasn't a whole lot of information. We got some of the dimensions, we've got the vectors, and we got the video showing the assembly, not really the layout and stuff. So where to put the fillets and all that good stuff. And hopefully I can do that for you here. So let's start off with our arched parts. I'm going to move them onto the screen. And I'm going to hold down the control key. When I'm in transform mode means that I have double clicked on the part. When I'm in transform mode, I can hold down the control key and I can drag up a copy of this. I want 2 of these. And on these parts, I need to make sure that the board that I'm cutting them out of is 1 inch thick. That's how thick they are. So let's go to our sheets, get our sheets laid out. And then we'll put our parts on our sheets and we'll create our toolpath and the fillets and all that good jazz. So sheets are boards. So some projects require multiple boards to be cut out of, and this is a case of that. And so we're going to create, we need 1, 2, 3, 4, 5 sheets for the hall table. So we're going to add 2, 3, 4, and 5. I want to go through and I want to rename them. So we're going to call this the top. We're going to call this our shelf stretcher. Stretcher. Hold on a second. I'm an idiot. How bad am I at spelling? There is a T on stretcher. All right, so we want, let's go back in there and rename that. So our shelf stretcher. Let me get rid of that number 3 for some reason. We're going to have our arched. Well, that's the wrong one. This one up here is going to be the arched stretcher. And side 1. Or you can go left, right, doesn't matter. I'll just go, yeah, side left and side right. Okay, so our arched stretcher board does not need to be 36 inches in length. Our parts alone are only 24 inches wide and everything. So I'm gonna go just a little bit bigger, a little bit larger for clamps and whatever purpose. I'm just going to go a little large. So I'm going to go 25 inches in length, and I don't need 12 inches. I might be able to get these out of an 11 1/4 or so. I'll go 11 1/4. You can go 12. That's fine. That's no big deal. You're going to have to glue up the panels for a lot of these, and they're 1 inch thick. I'm still touching off on the material surface. I'm still working in the bottom left corner. And now, I am cutting these parts out. I do want to guarantee that I cut the parts out and not beat up my wasteboard. And in the video, these guys beat up their wasteboard. They do. They actually use their wasteboard. They cut into their wasteboard to create ghost outlines of the board so they know where to clamp the board on the table and all that stuff. And my heart was, I was cringing. I was like, carve grid lines in your wasteboard. Don't beat up the wasteboard like that. But they did. But they're using a wasteboard exactly what it's meant to be as a wasteboard. They screw into the wasteboard, which is okay for some of the parts. We'll talk about that here in just a minute. But yeah, now, so 1 inch thick. I think I'm gonna reference off the machine bed because I am cutting through, and I talked to you guys about that in the past. Let's go ahead and click OK. And let's get these 2 parts. I'm using the alignment tool, align to center the material to get them on the board, right? Wonderful. Okay, let's go ahead and take our shelf stretcher, right click on it and move to sheet, shelf stretcher. Let's take our side here, right click on it, move to sheet, we'll go left side. Let's grab our top here, move to sheet, top. And let's go into these sheets. Now I can double click over here, or I can just double click on the screen to get that sheet to become active. And I want this part to be centered on the material. Okay. The shelf stretcher, same thing. I want that part to be centered on the material. And I'm a big fan of trying to save waste. I might move it over to the left in case I have something else that I want to use to cut out. I'm always trying to multitask with my boards and stuff, but for now that's good. Left side, let's get that centered onto the material. There we go. Now on the left side, I'm going to hit Control C or copy, and then Control V for Victor, which is paste, or I could do it, I could right click on the screen and go copy and paste here. I could use the keyboard shortcuts. Whatever the case may be, I can go up here and do it at the tools on the top left. I'm just going to, with this part selected, I'm going to hit Control C to copy, Control V to paste. So it pastes the copy right on top of the one that's there. And while it's highlighted, I'm going to right click and move to sheet side right. Okay. So there's my 5 parts. Okay. Okay. Awesome. Now, guys, I'm just talking and everything. I haven't gone over to the questions yet. I will go over and look at the questions here in just a minute, just in case there are any. But I'm just kind of walking through. We do have 3 tables to cover, and I want to try to, I want to be able to get them all in there and stuff and everything. So I will try to answer questions if any pop up. Throw some, so when I do glance over to the chat, if you do have a question, throw a couple of question marks, 1 or 2, I don't care, in front of your question, so visually I can see it, and all. So awesome. There's also super chat if you want your question or your comment or your statement or whatever to stay, stay up and be highlighted for some period of time. You can always do a super chat or super sticker. It helps support the channel. All right, let's go ahead and let's now talk about our parts, and let's talk about our pieces and everything. So for this, I'm going to go to SketchUp. Okay, so we can look at the actual parts and look at the actual joinery. Okay, so if you notice on the outside of the table, we have these mortises here. They're through mortises and stuff that are just these 4 squares. But if we were to turn this around, and let me hide these parts for a minute. If we were to turn this around and look at the inside cut, we actually have a larger pocket that's going down to a certain depth here. And then those square vectors, you'll see the vectors when we go back into the Vectric software. They're going to be through cut, but there's a lower pocket here because the way this arch piece is created, instead of having the tenons go into the part and then coming off the side, we have this nice straight arch and then it comes out. We want the part to actually start from the arch. So if I were to look at the other side, you can see that it goes right up to that, and from that arch, it's a nice clean arch, right into the side. That arch ends right into the side. It's a very nice joinery technique to just give that illusion, that nice illusion, when in fact our part is actually cut like this with these 2 straightaways. If I were to draw a line here, that part is going to be recessed up into our side all the way to there. And it is not a through joint. They will be slightly flush here. And they'll be, you know, sanded smoothly and all that stuff when all is said and done. So it's a really nice illusion. It's a really nice look to give that nice arch. And there's going to be a double arch. There'll be two of them. Let's unhide that last there. There'll be two of those, and that's going to give that hall table a really nice look. Now, the lower shelf joint, the lower shelf is actually 3/4 of an inch thick. And let me express this, and they say it in the video too, and I really think that it's important what they did here. Now, when I drew a lot of the parts and everything in Vectric, when I laid out all the boards I did at 1 inch thick, except for the top was 1 1/8 inch. But I did everything else, the two sides, the arched, and the shelf at 1 inch thick, right? And I thought, you know, I don't want to, you know, have different size materials and all that stuff, but that was stupid. It was stupid thinking. It was wrong thinking, because you want those different thicknesses in your project. You want to emphasize the heavy areas, and you want to emphasize the lighter areas and all, like the shelf. The shelf being 3/4 of an inch thick is a little bit lighter than all the 1 inch thick, you know, rest of the parts. The lid being 1 1/8 inch, that 1/8 of an inch thickness gives that lid, that top, some definition. You know, it sets that top apart from the 1 inch thick sides and the 3/4 inch shelf. Having the different thicknesses and accenting those different thicknesses is a nice touch. It's a really nice touch that they did. But I didn't know that they did that. Here I did. I knew that this was a 3/4 inch thick and everything. But if we were to look at, unhide all. If we were to look at, let me explode this one. And let me hide this and one of these legs. You will see on the legs that I have a 1 inch thick piece here, but I have a 5/8 inch thick tenon, right? And that, in order to accomplish that, it would require a two-sided job, that I'd have to flip my board over to cut this side of the tenon, clamp it, you know, flip it over and register it, and cut this side of the tenon and all that stuff. And it was incorrect thinking. What they actually did were the stretchers, if you will, the cross stretchers in the round table, they actually used 5/8 inch thick material instead of 1 inch thick to give that, again, that definition of that, the heavier areas, the four legs, the 1 inch thick top versus the 1/2 inch thick shelf. That shelf is a 1/2 inch thick. And the 5/8 of an inch thick stretchers and everything. Those different thicknesses, accenting the heavy versus the light and everything, really brings the whole elegance of the piece together. So when I drew these in SketchUp, you'll even see here that, let me hide this piece, that on the joinery, that I even created extra vectors that would have to be mortised out to bring that 1 inch piece down to 5/8 of an inch thick, so that when the parts fit together, you know, everything fits nice and tight, and, you know, nice clean joinery and stuff, which could be done, right? Which could be done and everything. However, it was the wrong way of thinking. Not everything has to be the same thickness, and not everything is the same thickness in this design. Where I faltered, or where I assumed that, was because in the round table, they show, let me zoom into this. they show the thickness of the tenon coming through in that mortise, but they don't emphasize the size of the stretchers, the thickness of the stretchers. So there was nothing there showing the thickness of the stretchers in the design. So it was assuming that, oh, everything's 1 inch here. They got a 5/8 inch tenon, so I have to create shoulders on each side of that tenon. So, you know, 3/16 on this side, 3/16 on this side. So I have my 5/8 inch tenon, you know, and that was what my thinking did in the design and everything and all, because I didn't have the information. It wasn't given to me in instruction, PDF, or anything like that. But it was the wrong assumption, because in the video, finally in the video during the assembly, they talk about the elegance of the 5/8 inch thick stretchers versus 1 inch thick and everything, and having those lighter parts versus the heavier 1 inch thick parts and all. And it made total sense at that point, but I didn't watch the video until after I did all the designing and everything, right? The video I watched last. Because there was nothing in there as far as designing. It was all just the assembly, right? And everything. But they had some key points in that video, so I really recommend you watch the video. The link is going to be down in the description of this video and everything. So, that being said, and everything, the hall table has that 3/4 inch stretcher, has that 1 inch sides and the 1 inch arch stretcher, and then the 1 1/8 inch thick top. Now, let's talk about the top here just for a second. On the top, and let me get over here. I'm going to flip the top over. So bear with me a second here. Okay. I'm going to flip the top over here. And notice they have these mortises here. And of course, those mortises are for the tenons that are at the top of the side. And there's some T-bone fillets that aren't drawn into the SketchUp design here, but we will be creating those in the Vectric for the cuts. But the mortises and everything are here. And then we have this 120-degree bevel. So from the top, remember the top is upside down right now in this view. From the top, we're coming about 1/8 of an inch and then into this 120-degree bevel. Now, they cut this bevel on the table saw. Okay? So this part here, is actually, you know, it's 120 degrees outright, but it's 50 degrees on the table saw. So we can, you know, turn the table saw to 50 degrees and just slightly over 45, and we can run that part through to cut those bevels on the table saw, right? And that's what they did. We could also create that bevel using the chamfer toolpath and a ball nose bit, or even a V-bit, might be a different angle. But if we want to stay true to the design, the 120 degrees, which is 50 degrees on the table saw, they simply cut the table down to size 36 by, what was my tabletop? 36 by 10 5/8. They have a 120 degree bevel there. And the only thing they cut on the CNC were the mortises. For the top. They let the CNC do the important joinery cuts, the mortises and the tenons and stuff. So the mortises. So you could do the same thing. The top doesn't need to be cut out on the CNC. It can all be done at the table saw, but the mortises will get cut. Okay. Now, depending on our CNC setup and everything, you know, to achieve that 120 degree bevel or 50 degree bevel, depending on how you look at it, the chamfer toolpath, I believe it would require a ball nose bit. We'll take a look at that. But those are the parts that we're going to be starting on. So let's go ahead and get over there and do that now, because we're wasting time. Okay, let's start with the legs, since there's 2 of them and everything. You will notice that on the leg assembly that we have these vectors here. We have this rectangle vector here, And then we have this vector here. Okay. And if we look closely, they've got a vector thrown in here, right? And that's a mistake in there. If you look in here, we should have a rectangle for our pocket cut, and we should have two other rectangles in here for our through cut. This part shouldn't be there, right? The way it was drawn up in their CAD program, it kind of created the vectors incorrectly for what we need for our toolpaths. Okay, and then here, I'm not sure what happened there, but you can see that little vector right there because this vector did not close all the way, right? There's a line there instead of a rectangle. Like, you know, they don't match as far as, you know, I can click on that, that's a rectangle. This one is individual lines, didn't join properly, and then it created, you know, there was some kind of mistake right there, right? We're going to fix it. So, but we're going to fix it to what we need because we don't need this. We do need the outer perimeter here, but we don't need this rectangle. We need actually two rectangles for our through cut. Our mortise goes all the way through for that inside pocket cut, right? So, that being said, I'm going to go ahead and open up the Draw Rectangle tool. Is everybody with me? Good. Everybody with me? Cool. All right. I'm just going to, I've got Smart Snapping and Geometry Snapping turned on. And I'm simply going to just draw a rectangle right over this one here. Okay. And I'm going to do the same thing here. Get on that corner and draw a rectangle there. Cool beans. Here, I'm going to draw a rectangle here. And I'm going to draw one here. Now, I didn't go left or right or up and down or top to bottom for any particular reason. It was just easier for me to, you know, I didn't know what was going on over here, so I didn't want to snap to that corner, right? I wanted to just snap to a corner, you know, when I was drawing and all. Now that those two rectangles are created, right, up here we don't have a whole lot of layers, and I want to work with some layers, right, to help us out and stuff. So I'll go ahead and rename this layer here. Rename, and I'm going to call this my arched stretcher mortise. And the new layer, add another new layer, and this is going to be same thing, but it is the arched stretcher through mortise. It's got a long name, but we'll leave it at that. Okay. Now, the two vectors that I just drew, I'm going to select them. Now, they're on top. I drew them on top. So when I select these, I'm clicking, and it's selecting that top vector. Okay? It's not selecting anything underneath. I didn't drag my mouse around it to select them all and all that stuff or anything like that. I didn't just do this because that's going to select whatever's underneath or anything like that, which in case there's nothing. But I'm going to click on it. I'm going to hold down the Shift key, and I'm going to click on this one, and this one, the four rectangles that I drew, and I'm going to move them to the through mortise vector layer. And I'll go ahead and give that layer a color of kind of red. You know, I don't know if I can see that red on the screen very well, but it is red there. Now what that allows me to do is I can turn off the visibility of those, get rid of them. And now what I'm left with is the two rectangles, which are going to be my shallow mortise, right? My shallow mortise. So I can go ahead and move that to the mortise layer. And I can turn off the visibility for that. And notice that there was a duplicate underneath that one, with all these lines and stuff and everything. And that's all trash. We don't need any of that. We don't need any of that. I don't know why I'm looking over here when you're right here. All that's trash, right? So that gives me the ability to delete that. And then I can turn on my, notice here, that rectangle, right? That was their drawing. I didn't redraw a new rectangle, but we'll fix that here in just a second. And we can also turn on the individual rectangles and everything that are going to be the through cuts. So here we have this issue here, right? Simple node editing. We can simply come in and delete this point and delete this point. Okay. And points A to B, we don't need them, or we don't need anything in between here. So we can go ahead and delete that point and that point as well. We only need points A to B to C to D, right? We don't need anything in the middle. So we want to just clean it up. So we just had to get rid of those extra points, you know, that extra lower line, get everything all cleaned up and stuff. All right. Now, normally this is where I would tell you that we would need, in order for this to be a, you know, a joint and everything. Oops, give me just a second here. In order for this to be a joint that we're going to be doing on the CNC, that we would need dog bone fillets or T-bone fillets, you know, and dog bone fillets, these create a clearance on the inside corners, you know, where, you know, two parts are going to fit together, in this case, a mortise and tenon. A T-bone fillets creates a clearance where the internal cut is the same diameter as the bit, kind of thing. It's not always the rule, you know, why you would use one versus the other, but that's typically what it is. And if we did that, you know, let's say I was using a 1/4 inch bit to cut out these mortises, that means my radius for my tool would be 1/8 of an inch. And I would go through, and on all of these corners, I would create these dog bone fillets, right? No. In this case, we're not going to do that because we don't want the ugly eyesore of those fillets when that tenon comes in, you know, and everything. We don't want that, even though it's on the inside of the leg, you know, and you'd have to really look to see it. It's cutting all the way through. When it does the through cut, it's going to create that fillet all the way through, right? So you'll see it on the outside too. And we don't want that eyesore. In this case, what they did and what they show in the video is they rounded off, after they cut the parts out on the CNC, they rounded off the edges of the tenon so that it fits into this part when it gets cut. Because remember now, when the part actually gets carved, it's going to create a rounded tenon here. Okay. Now they didn't round all the parts on every one of these tables, just the first two. But the round table, they used a chisel and did some squaring up of the actual mortises and all. But we'll get into that in just a minute. So when this part gets cut, it's going to be rounded like this because of the radius of the router bit, that 1/8 inch radius and everything. And you can't fit a square peg in a round hole. So the tenon of those arch tenons and everything, and also the shelf stretcher down below, they rounded the edges of the tenons so that they fit in. Okay, so they took the round over bit, rounded off so everything fits in. Okay, they did it with a router, hand router, and some sanding and stuff like that as well too. You know, little chisel work to shave off that corner and round it off. So there was some hand work involved in everything. Now, so other than cleaning up the vectors and creating the proper vectors that we need, which are, we need these 4 cuts for our through cut. We need these 2 cuts for our shallow cut and everything. Aside from that, everything else is, you know, good to go. Now, if we look, go back to SketchUp here, and I'll hide this side. Hide. Okay. If we look here, all right, remember now, the tenon is going to go all the way into the part up to this line. And our mortises come to here, right? So our mortise and everything, our through mortise and all comes to here. Now this block of wood, that's going to be what's remaining in the side piece. You know, when it's cut, let's come over to this side and take a quick gander at that, right? That's going to be remaining. And the depth of that cut from here to here, that 1/2 inch depth and everything, that corresponds, let me get back over here. That corresponds with the depth of the tenon. Okay. Now, the tenon is a 1/2 inch thick, right? And the remaining part is also a 1/2 inch thick for a total of 1 inch, right? That's how thick our side is. This is important for those of you that are just now getting new to woodworking and all that stuff and all, and you got a CNC, but you haven't really done a whole lot of woodworking and stuff like that. Sometimes when you're doing tenons, mortise and tenons, and the tenon is exposed, or you can see the tenon on the outside. So if I edit, unhide all, where you can see the tenon on the outside, you know, here. And you have that nice little, you know, that ingrained look, you know, on those 4 spots and everything. Sometimes when you're doing the assembly, you want that tenon to be just a little proud, not like extravagantly proud, but proud means it goes past the part. Okay. So when those 2 parts fit together, you want that tenon to be just a little proud so that when you're doing your finishing sanding and everything, you can sand it flush and have a really nice joint. You don't take the chance that your parts, you know, are perfect and all that good stuff, and that when they fit together, that piece is going to come right flush to the front. There's not going to be any gaps or anything, so you know you don't have to do a whole lot of wood filler and all that stuff. You kind of give yourself a little bit of proudness, a little bit of exposure so that you can sand everything flush and really bring it to that nice finish, right? Well, in their design, the tenon being a 1/2 inch and the remaining part that goes in being a 1/2 inch for a total of 1 inch, it doesn't really leave a whole lot for a little bit of proudness, right? So in SketchUp, in Vectric and V-Carve, in our parts here, let's make the arch stretcher an active sheet so we can work on it. Here and everything, when our 1 inch, and I'm going to draw a 1 inch wide square, 1 inch wide square. When that part comes in and fits here, right? When that leg goes in and fits into there, and of course it looks something more like that, right? When it fits into there, there's not a whole lot here left for proudness and all. So what I'm going to do, or what I would recommend for you to do as well, is I would recommend that we go into node editing. We grab these 4 nodes on the end of this tenon and we bump them out ever so slightly. Not a whole lot. It doesn't have to be a whole crazy amount. Just a few thousandths of an inch, right? So I'm going to use I've selected those 4 nodes that represent those tenons and everything. And I'm going to use my right arrow key on my keyboard to just bump them out. Now, how far do I want to bump them out? I can be really specific on it and everything. I could use a guideline to help me. I could say, okay, on my guideline, let's right click and let's create a parallel guide, and let's go 20 thousandths of an inch. We could go a 32nd of an inch, right? Whatever you want it to be. And also, I'm going to go 0.02, just under a 32nd. All I need is just a little bit, you know. If I want to be safe, I could go a 32nd, 0.3125, right? I want to be more than a 64th. I could be less than a 32nd. I could be somewhere in between, right? Whatever you want, but just something, okay? When we create that guide, and I don't want to go that much, I do want to be, let's go a 64th. So that's 0.015625 is 1/64th. Let's go ahead and create that. And that's what I bumped out to. Let's get rid of this guy. Just overshot that 64th a little bit, right? So let's back it up. I want to be kind of precise about this. I got node editing at my side here. I can select those 4 nodes. I can really zoom into my guideline, and I'm just going to use, I could use my back arrow button, and I could back up to the line, or I could have drug it to the line too. I could have drugged that to the line and everything and all. But now when I go to assemble this into that leg, I'll have that 32nd of an inch proudness there, or 64, sorry, proudness, that I can sand flush, right? Okay, so I can sand it flush and all. And now our other tenons on the other tables, they're through tenons. They're designed to go through, so no worries there and stuff like that. But these on the hall table, the shelf for the stretcher and the arch stretchers, they're not. So what I want to do is while I have these parts, I want to come in and snap my guideline there, because what does that do for me here? That gives me the ability to select these nodes, and I can drag those nodes right out to that line, right? So everything is nice and even. I can get rid of this square so I don't confuse myself and wonder what is that square for when it's actually nothing. That was me just showing you the assemble like of the joinery. But do you get it? If you get it, give me a thumbs up and like you know, in the chat area and stuff. And let's go from here. Now I'm going to right click on my guideline. I'm going to create a relative guide, 0.015625, and I want a negative number. I'm going to the left this time. Left is negative, and I want to create that parallel guide to the left. There we go, right there. And now I can come in and go into node editing. I can select these 4 nodes, and I can drag them out to there. You can use your arrow keys or you can drag, right? Let's do this one. Select these 4 nodes and drag them out to there. Now, at no point in time in the video, in the design you see here or anything like that, does it talk about the proudness or sanding flush or anything like that. But if you've done joinery enough or anything, you'll know that, like when it comes to dovetails and finger joints and things like that, having that little bit of proudness on that assembly, it doesn't have to be a crucial amount, but being able to sand that flush and everything, and if there are any voids for whatever reason or anything like that, when you're sanding, a little bit of glue, a little bit of sanding sawdust really fills in those joints nicely and all. But in this case, it just gives us that ability to sand nice and flat, so we create that nice smooth surface on the side of that leg, right? All right. And so I think having this class, and Mark Murphy, you know, recommending, you know, to have this class and all to talk about things like this. These are things that didn't show up in the drawing. They didn't show up in the DXF files. They didn't show up in the video or the discussion of the video and all. But when it comes to the woodworking and the assembly and everything, it's important. I think these little details make a big difference, and everything. And Troy, please go into explanation on as long as the board thickness is consistent, because our sides, you know, we're going to be milling them to 1 inch thick, and if they come out, if they're not 1 inch thick and all. They damn sure better, those two faces on the inside of my leg and the outside of my leg, they better be parallel planes. They might be a little bit more than 1 inch thick. They might be a little less than 1 inch thick. But they better be parallel. I better not have a leg that comes in like this or anything. So as far as consistency, they're going to be a consistent thickness, but they might be a different thickness. They might not be 1 inch. They could be 1 1/8, 1 1/16, 0.99, 0.97, but they better be parallel, and I'll know that. And when I cut my parts and everything, I might decide to cut my legs first, measure all my thickness, my material, so that my joining parts, I can come in and alter the designs if I need to get that proudness a little bit more. I'm thinking ahead, right? So, but they better be parallel faces. There better not be any inconsistencies in my wood thickness coming up the length of that leg. All right, cool. All right, so, yes, it does make for a nice looking end grain and everything. Now that while we're in the mode of node editing and getting things out, let's come look at our shelf stretcher, right? Our shelf stretcher here, which is the other part that fits into the side of the leg and everything. And if we look at our shelf stretcher, if I come in and measure, horizontally, from the end of that tenon to the inside shoulder here, it's right at 1 inch, the thickness of our leg of our tables, right? So again, it's the same thing as the upper stretchers and all. That's assuming that, that everything is, when it fits and all, that part is going to be nice and flush to the outside of the leg, and our legs, aren't a little off or anything like that. It doesn't give us the ability to kind of work to that finished part, that finished part and all. So on the stretchers, same scenario. I'm going to go in and I'm going to snap my guideline to there. And I just want a 64th. I just want a little bit. Give me a little bit of room to play. I do not ever want to change the inside, because I do not want to reduce, because if I change the inside now, very important. If I said, well, what if I can just back these lines up, right? I could back those up just to make the tenon a little bit longer. I can shorten this here. Well, if I do that, that brings my legs having to get closer for the fit, which changes the mortise and tenon space position on the lid. It changes everything in the whole design. We don't want to do that. We want to keep our span consistent. We are simply just expanding the length of our tenon, that waist area that's going to get sanded flush to that final finish. We are not changing. We're not going left. We're not bringing these in by a 64th, because then that changes the width of our, when this joint is put together, that changes our width of our span here between our table legs. And if our legs have to get moved in, that changes the tenons on the top, those 4 hole positions right there. That changes all of that, and it changes everything. Don't do that. Don't screw yourself up like that. We're going outward, okay, in the waist area. Okay, so we're going to create a relative guide. We're going to the right. It's a positive number. Let's create that. And again, look how small. I mean, it's just a 64th, right? We're just giving ourselves a little bit of working room. You can go more than that if you're like, I want to give myself a lot more working room. I don't mind sanding it down flush. You can go more than that, but really it usually doesn't take a whole lot, right? If you are consistent with, like Troy mentioned, if we're consistent, if our legs are 1 inch thick, that 64th is a big deal. I mean, it's proud. When that joint goes in, we're going to be proud that 64th, we can sand it flush, and it's not a whole lot of sanding to get to where we need to get to, right? But if there is an inconsistency and your leg is parallel but wider, then you want to extend that tenon out more so that you can be proud and sand through flush. Give yourself whatever working room you think. I'm going to make sure my legs are exactly 1 inch in thickness and material and all with my planer, my drum sander. Hell, my CNC can surface the whole board to thickness, and I'm going to make sure I'm consistently 1 inch thick, so that way all I need is that 64th, right? So let's go into node editing mode now. I just hit the letter N on the keyboard. When I selected the vector, and I hit the letter N for Nancy for node editing, that turns in node editing, right? So now I can come in here and I can select those 2 nodes. zoom in, get yourself close and work it, and come over here. Cool. All right. We can then, I'll drag one of those guidelines over to here. This one I'll just get rid of. Make sure I'm snapped right on the edge there and right click. Relative guide, this time I'm going a negative number because I'm going to the left. Create that. And go back into node editing, letter N on the keyboard, grab those two nodes, zoom in, get yourself close, up close and personal, and drag. Or you can use your left arrow key if you want to as well too. Drag out to there. You're done. Get rid of your layout lines, drag them back over into the ruler, and boom. Okay. All right, we good? Good. Okay. All right, so that takes care of our two tenon pieces, our arched and our shelf. It gives our parts and everything that little bit of extra proudness that we can sand flush. All that stuff is gone. Now what we need to do is I want to get out of node editing mode. I want to go to the right side table here, right? And, you know, why draw what you can copy, right? Why draw what you can copy? Now, remember, these have those bad, you know, this right side, same thing we have to do. It has those bad vectors and all that stuff on there. And we've just created all the good vectors over here, right? Well, I'm going to go ahead and delete this. I'm going to go back onto the left side. I'm going to make sure that all my vectors are turned on here. And I'm going to select that all and copy that. Oh, gosh, hiccups. I'm going to copy that. Copy to sheet. Remember before I did copy and paste and then I moved? Well, I can just copy to sheet and that works too, right? So showing you multiple ways to do things. And I want to go to the right side, right? So it copies that part over there. Now, something very important. On your wood, these legs, and let's talk dimensions here just for a second, okay? Let's take some measurements so you know what you're dealing with and stuff. A vertical measurement, the width of this leg from the top to the bottom is 11.5 at the top and 7.6008 on the bottom, or at the top, right? And that's fine. CNC is going to cut that out, you know, that profile and everything. It's going to cut it all out. So, it doesn't matter that it's funky like that, but it is. All right, now, the 11.5, most boards, like a 1x12, right? 3/4 inch board by 11.25 is a 1x12, right? Well, we want, for our side parts, this is lumber. We are going to be gluing up. You're going to be doing edge gluing, so go to Harbor Freight, get you some clamps, get you some Type Bond glue. Don't get it from Harbor Freight, get the glue from Lowe's or Home Depot. Get you some Type Bond 2 glue, and get you some, while you're there, get you some Type Bond hide glue. And the reason why I say that, we're thinking ahead because in the metal inlay classes that are coming up, hide glue is what we're going to be using. So get yourself some Type Bond hide glue from Lowe's while you're there. But get yourself some Type Bond 2, and you're going to be doing some, get you some clamps because you're going to be doing some edge gluing to glue up these panels, right? You know, there's all kinds of videos online for techniques on how to, you know, if you don't have a joiner and a planer and all the fancy tools and all that stuff, if you have at least a table saw, how you can, you know, joint on a table saw or a router table and everything so that you get nice glue joints between your parts, right? We want to create a panel, and our panel again your panel is going to be, in this case, 36x12, right? 36x12. For most all the parts, you don't need 36x12 for the small shelf. We'll talk about that in just a minute, but we'll talk about the board thicknesses in just a second. But you're going to be gluing these up. Now, when you do your glue ups, right? When you do your glue ups, your glue ups and everything, you don't need any dominoes or biscuits or any of that stuff. It doesn't help at all mechanically. It just helps with alignment of your parts and everything, so they don't shift and all that stuff and everything, and all. But you're just gonna do a straight edge glue, and generally you have a good face and a bad face, right? You know, you have one face of that board that looks better than the other. You got to think about on your layout and stuff when you got these 5 boards, you know, all glued up and ready to go to get put on the CNC table. And I'm going into a long discussion here because so that way I don't have to repeat all this stuff or go into that discussion in the other. You'll get the idea as we go through the other 2 tables and everything. But when we have our boards all glued up and everything is ready and we're sitting at the CNC machine and we're ready to throw them on the table, clamp them down and do our cuts and all that stuff, we're going to be picking, you know, our faces and everything. And for the most part, like these cuts here and everything, the legs that we cut, we're going to be cutting on the inside face. So that's going to be the face that's facing up when that CNC is carving and everything. That's going to be the inside of the leg, not the outside that's going to be exposed. So you want to make sure that the pretty side of your board is facing down, right? In this case. Now, and the same thing here, we've got our left and our right leg, right? Now, we could mirror the part here. I don't have them mirrored right now because I assume that, you know, when I bring this leg up and I just rotate it around 180 degrees, it'll be the right leg and the left leg and all that stuff. But if I have, for what odd reason, it doesn't, I mean, it's 2 sides of the table separated by 24-inch spans and all. They're not bookmark matched or anything like that, so it really doesn't have to be kind of that, you know, that sandwich, you know, left and right leg. Just know that we're carving on the inside of the leg, so make sure your good face is down, right? Okay, it doesn't matter which leg is left and which leg is right, okay? But if it does matter to you, then make sure that you mirror or rotate the parts appropriately and all that stuff and blah, 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 right? For left and right and everything. Okay, okie dokie. All right. Now, and basically what that would entail would be, you know, rotating, you know, one part 180 degrees this way and this way, right? Right. That's all it would entail. But it doesn't need to be. It doesn't need to be. We can, when we cut that leg, we can turn it around. It could be the left leg or the right leg. It doesn't matter. It doesn't matter. Unless you're like, hey, the right side of my couch table is kind of up against the wall. It doesn't get to be seen. The left leg of the hall table gets to be seen the most. You know, that's what they see when they come in. I want this board to be my left leg and this board to be my right leg. Then make sure you're flipped the right way, right? All right. Okay, cool. Beans. All right. Anyway, so it doesn't matter which way they're facing. All right. Now, get back here. Okay. What's important is the proper face is facing the right way and inside. The shelf side, right? The top of the shelf. It doesn't matter what side you cut. The pretty face can be up on the shelf. That can be the pretty face, you know, because we're just cutting. It's a through cut, nothing there. The table top. This is the bottom side. That's the bottom side of the tabletop. So make sure the pretty side is down. The arched ways on your arches. These, you know, they can go in like this or they can go in like this, right? So it doesn't matter which one's the pretty face. Just make sure that, you know, you have a pretty face on one side, and, you know, because they're both going to be cut out of the same part, you know, that kind of deal, right? We're not mirroring this and everything. You know, on that board, try to make it look as pretty as possible. Because I don't want to waste a whole lot of wood by trying to flip one part up this way and one part that way, so that, you know, I'm not going to deal with all that. If I'm going to deal with that, then I'm going to have individual boards. If I want to deal with that, if I want to make sure that on my arches, you know, that I got a pretty face on both sides, they're on the outside and all, which makes, you know, respect to you, then my board, I'm going to do these individually, right? So I'm going to have, you know, one board. It'll be a smaller board. It won't be a 12-inch board by that point. But I'm going to have one board cutting out the left arch, one board cutting out the right arch, right? So if you're like, hey, that makes more sense because, you know, if we're worrying about all the faces and everything and we want good faces on the arches too, so then do it in separate boards. That's totally up to you. So if that's the case, then our arch here has a total overall height of about 6 5/8, right? So going into our sheets, let's create a new sheet. And arched left, and rename this one arched right, that kind of deal. And we'll make sure that pretty face is up on these. So if the pretty face is up, that's the outside of the right. This is the right side. Left side, pretty face is going to be up. So that would be the proper facing for that. All right, so let's let's move this one. Move to left arch. And let's center that onto the board. Okay, let's get our board sizes. We should have done this right at the beginning, but I want to get talking about all the joinery and the fitting and all this stuff. But let's get our board sizes down to, proper sizes. So our arched boards, again, they only really need to be about 7 inches wide. We're going to edit this, and we can go 7 inches because, again, from the bottom of the arch to the top of the arch is only 6 5/8. So 7 inches is all it needs. And we can go ahead and center that. Okay. And again, there's some waste area right here. If you have other little projects that require a 1-inch thick piece of material or whatever, and you need something to cut out, throw them in here while your CNC is carving. Have them carve them out too. Multitask, multitask, multitask. All right, let's go in here and let's size this one. Sheet, the right edit, 7 inches. Okay, let's go ahead and center that onto the board. Beautiful. All right. Our left and right sides, they really, the sides are 29 3/4 inches, 29 3/4. So 30, 31 inches. They don't need to be 36. They can, you can just make sure you got room for clamps and all that good stuff and blah, blah, blah. So the left and right side, let's edit that. I'm going to go ahead and just make them, I'm going to go 31. And keeping the 12. Got to keep the 12. All right, let's get that centered on the board. Okay. Right side. $31. Keeping the 12. Again, you're gluing up these panels, so give yourself, a little bit of working room. Doesn't have to be a whole lot. Just make sure it fits on your CNC. Okay, the stretcher shelf. Now, the stretcher shelf itself is only 24 1/32, right? Because we went a 64th on each end, right? So, for that extra proudness. So, but 24 1/32, and it's only 6.5 inches wide. So we can go on that shelf, edit. I'm going to go 26 inches, and again, I'm going to go 7. Okay. All right. Now, one important measurement that I missed is the thickness. The shelf board is only 3/4 of an inch thick. Okay. The arches are 1 inch and 1 inch. The left side and the right side are 1 inch. So let me fix that. Left side is 1 inch, not 1.25 inches, 1 inch thick. The right side is 1 inch thick. The top is 1 1/8 inches. And so I've got my 1 inch boards that I'm going to be gluing up and everything and milling and gluing up and all. I need two 31-inch pieces by 12. I need two 25-inch pieces by 7, right? And that's that. And then I need one 36 by 12 that's 1 1/8 thick. So that one's going to be milled a little bit thicker. All right. Again, you can make them whatever size you want. These are just the sizes that we're working with here. So on that stretcher shelf, let's go ahead and get that centered on the board. Let's get rid of that measurement. Beautiful. All right. So we got all our layouts. Now, final thing, and then we can move on, is we got to do our fillets. We'll talk about the fillets now, the fillets and everything on the joinery, where the fillets are going to go and why we're using them and what we're using them for and all that good stuff. But before we do that, let's go ahead and let's answer a quick question. Brooks Martin says, Laney, on your glue ups, do you concern yourself with the growth rings? Well, most of the boards that we're gluing up and everything, you know, unless they're, you know, quarter sawn oak or whatever, you know, board you're working with, unless they're quarter sawn or all, most of them are flat sawn. And you're going to have, if you look at the end grain, a lot of times, because you're going to have those rings and all. And so those rings kind of indicate, if, you know, depending on how dry or your environment and stuff is and all, they kind of indicate the way that board, if it were to shift or move or cup, the way it's going to cup generally. You know, very rarely does a board ever warp or twist against kind of the end grain, the way those rings are going and all. Some people, when they're doing edge glue ups, to minimize their boards cupping or crowning or anything like that, they will alter or flip the grain, the end grain, you know, so you have your rings going this way on one board, your rings going this way on another, and so on and so forth. I very rarely do I worry about that. Most of the wood I work with is it's stabilized, it's acclimated and all, and I know it changes, and wood is never fully stabilized and everything, you know, and there is going to be wood movement, you know, throughout the years and stuff like that, but very rarely is it going to be that much movement that it makes that big of a difference and everything. And I really don't I don't alternate my grains a lot unless it's a large panel that there's not going to be any other joinery to help keep it assembled. Our top, when it goes in, our top is going to, you know, keep that board. That board's going to keep it from crowning because it's mortised into the top. It's not moving anywhere, right? You know, and then we have our, you know, our shelf joint, our arch joints, and all these joineries and everything. It's going to keep that board, you know, somewhat stabilized to where it can't really, you know, move a whole lot. So I wouldn't alternate the grain. But what I would do is I would make sure on my glue up that, you know, my face, the part that's going to be exposed, the outside face, looks good, right? It's going to be all about the grain and direction and all that stuff and all. But yeah, so now I don't really concern myself that much about it, but it is a consideration and all. Brooks. Grain orientation is important as well. Mixing flat sawn with quarter sawn, for example, rarely looks good. Exactly, that kind of thing. Exactly, Mark. Very important as to which side to carve. All that stuff, all that plays a role, right? And if I have a board that I've cut up and you know, and things, and and I am alternating the grain to do the glue up and all and everything, that's going to make for an ugly face in some parts and all. So what I do tend to do is I have found sometimes that like larger boards that would be really prone to cupping and crowning, I will rip them down and re-edge glue my whole panel up from those ripped down panels, instead of like two big wide panels gluing those together to make one big one, where the potential of them to cup and twist or whatever, you know, I'll rip them down into smaller strips and then glue them together. I am losing that 1/8 of an inch and all in the grain and all, but it does still looks like a good face and all that. But that way I don't have to alter the grain. Okay. Okay. All right. Cool. All right. All right. So let's talk about our fillets now. Now, generally, when we have two parts that fit together, all right. In this case, I'm going to draw a rectangle here again. Let's pretend. You know, I got a 1-inch part here. When we have two parts that fit together, that means that we have a mortise and tenon, right? We have a part that's getting cut out. And when that router bit cuts the tenon, in this case it's going to be this leg right here, we're going to have radiuses in the corner from that router bit. Now, we either are going to do a dog bone fillet, which again, you know, brings out an area for the router bit to go and everything, so we get those corners, those flat connection points and stuff. You can't fit a square peg in a round hole kind of thing. Or we're going to be rounding off the edges, the 4 edges of the tenon. So bear with me. Bum, 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 bum. Okay. All right, bear with me a second here. Imagine that this is a big tenon, right? Well, the tenon that's going to be fitting into that mortise and everything, we're going to round off the 4 corners so that they match. We're going to kind of round them off. And in the video, he talked about he used an 1/8 inch round over bit, right? A router round over bit, and he did it with that. When I'm rounding over, I will take a chisel and I'll shave off the corner, and then I'll sand round to get that radius that I want. And I'll test fit as I'm doing that into my mortise until I get that nice look, right? I don't want to overcut, right? I kind of sneak up on it. You know, he used because he was using a 1/4 inch end mill with an 1/8 inch radius. He used an 1/8 inch round over, which is an 1/8 inch radius, to round over those corners and everything for his joinery in the video. You can hear him talk about it. He doesn't show it, but he talks about it. Me, I'm using a chisel and sanding, and I'm sneaking up on the part. But either way, right? However you want to do it. But the 4 corners are going to be rounded over. And we're not going to do dog bone fillets. We're not going to be doing dog bone fillets and everything. And all, because we want, we're going to end up rounding over those corners. However, when that router bit, let me get rid of this rectangle here. When that router bit, 0.25, is doing the profile cut, right? When it's coming in here and doing the profile cut and all, it's going to create a radius here. And when we go to put that joint together, it's gonna bottom, because it's rounded here. You know, there's wood there, right? You know, it's only open right here where the tenon is. We can't get past that. We'd have to either chisel out that corner with a hand chisel and stuff. Oh, am I buffering for the first time tonight? Hold on, I'm buffering. Okay, I buffered a little bit, guys. Sorry about that. I buffered a bit. We are either going to have to chisel out that corner, or we're going to use what's called a T-bone fillet. So on the end of the mortises, we're going to use our fillet tool. We're going to put an 1/8 inch T-bone fillet here, and we're going to put that fillet. Now, notice where it put the fillet. It put the fillet here, and I don't want the fillet there. I don't want the fillet on this side. I want the fillet on this side. Okay? I want the fillet, because you got to think about where you're putting your mouse. I want the fillet here on the inside. Let me undo that. If I'm over here, then it's going to put the fillet there. You see that? And then when I put that joint together, now I have this unsightly hole that I can see on the shelf where it didn't go together, right? Well, by putting the fillet here, giving the place for that router bit to escape, when our mortise goes into our tenon, that gets hidden. It's inside the side of the leg now. It's inside, it's hidden. And this is the smart thing about the joinery that they did. So they did joinery so that they could get those square, joints and everything for that nice flat, when that board goes into that leg and all. But that router bit, instead of having to chisel that corner out, they used a T-bone fillet, and they made sure that the fillet was coming into the tenon, so that when the tenon is glued inside the leg, that fillet disappears. You don't see it ever again. It's gone, right? And it's great. Now we have a clean look, to our leg and all that stuff. So we want our fillets to be on the inside. Okay? And so we're not going to do the dog bone fillets on the mortises. We are going to keep the mortises cut the way they are, inside pocket cut and everything, and we're just going to round the tenons, but we're going to put dog bone fillets, or T-bone, not dog bone, T-bone fillets on the inside of that tenon, so that we get that nice, when that tenon goes in and that leg bumps up right against that shelf, get that nice joint, right? When it goes in there and get that nice joint and everything. All right, so that one's done. That shelf is done. Now, let's go to our legs here. Okay, same thing here now. On the inside cuts are what we have to worry about here. The inside cut, when this part goes in to that blind mortise and through mortise, it's kind of a combination of the two, we need our fillets, okay, to be this direction here on this. Okay, so that way when it goes in, because remember, we're sinking into the leg all the way. That leg, that 1-inch leg, is going all the way into there with square corners, of course. That leg and everything. So when that joint, bear with me. Let me draw the leg proper. Leg. All right, got that 64. So when that leg gets cut and everything and all, again, those fillets, we need them because we can't fit a square peg in a round hole. And there is a piece of material, there's a piece of wood here. Don't forget, there's a piece of wood right there, right? There's a part there, right? That, in our leg and everything. So when that router bit, when it fits up to that part, that router bit needs a place to go, so we don't have those radius corners. So our fillet is going on those arcs, so it's going this way and here, left to right. Okay, cool beans. So let's get rid of that and that. So we need to make sure that we put our fillets in the proper place there. Let's Do the same thing here, and then we're done with the filleting. In the video, the Woodsmith video, episode 14, Basecamp, CNC Basecamp, the link is in the description of the video. You'll see when he assembles these and everything, how those joints just disappear, right? So that is all we needed to do for our fillets, except for one more place. And that's going to be at the top that fits in, you know, the two tenons that fit into the top of our table. These tenons are coming in, and remember that router bit's going to be coming and cutting. It's going to be creating radiuses on these inside corners. But if I put a fillet in here, that T-bone fillet and everything, if I put a fillet in here and I, you know, make my fillet go this way, well, when that top goes on, you'll see that fillet, right? You got that ugly hole there now, right? So we want to make sure that our fillet is going in the correct direction. When that joint goes in, we want those fillets disappear, gone, right? We want that nice flat edge up against the bottom of our table. Okay, so there and there. Beautiful. And our other leg, T-bone fillet, ladies and gentlemen, T-bone fillet. Put your mouse, when you're doing those inside corners, put your mouse on the line where you want the fillet to go. So if I'm on this line, the fillet's going to go that way. If I'm on this line, the fillet will go this way. So we want to be that way. Okay? All right. That is it. This is ready for tool pathing now. And let's go ahead and do that. And yeah, should be able to get through the other two pretty fast, much faster and things. Here we go, Toolpaths. Let's go ahead and let's start with our through pockets. Okay. All right. So 1, 2, 3, 4, and the lower shelf one we can do together in the same toolpath. It's going to be a, you can do a pocket cut. You can do an inside profile cut. That'll leave little pieces that are floating around, you know, and all that stuff. But I'm just going to do it as a pocket cut. For me, it's the way to go. And we're going to go 1 inch thick. I'm going to use a 1/4 inch end mill. My end mill will be taking on this, it'll be taking an 1/8 inch per pass. I will be using an upcut end mill for all of this. An upcut spiral end mill for all of this. That's going to be very important when you're working with these hardwoods and everything. You use an upcut spiral bit. I'm going to be running my machine's a little bit smaller machine. It's not a big commercial machine. It could be running, you know, around 125 inches a minute or whatever on larger machines. I'm going to be running around 55 inches a minute with a 15 inch a minute plunge, taking an 1/8 inch per pass and a 40% step over. And this is going to be my, I guess in a better sense of the word, the through mortise, right? Through mortise, left side. Left side. And we're going to calculate that. Preview. Okay. Easy enough. You can see those fillets, right? The fillet is those rounded corners and all. You can see those fillets there and everything. All right. Now, we're going to take the two rectangles, and yeah, I'm just selecting them through the middle because they, you know, that's the exposed part. I can grab it there. This is going to be a pocket cut. It's going to be cutting a 1/2 inch, 0.5, 1/2 inch deep, and same bit. This is going to be my blind mortise. Left, side, left side. Calculate that. Okay, so we end up with that cut there. Cool beans. All right, and then our final cut is our profile cut. Cutting 1 inch. Now I'm zeroing out on the machine bed, so I'm cutting 1 inch. That's how thick my material is. Not 1.01, 1.06, 1.05, 1 inch. The cutting on the outside right line is a climb cut. I'm using my 1/4 inch end mill. Go 55 and 15. Now, tabs, the scenario of tabs and things. You can add tabs to your cut and all. The parts are quite big. These parts are quite big. And, you know, you could, as it's cutting out, when it gets to that last pass, you could just hold the part, you know, as it cuts through, so you don't have to worry about tabs and all that stuff. Totally up to you how you want to do it. You secure it, you know, with 2-sided tape or tape and CA glue. I mean, there's a lot of ways to hold your material, right? Now, I'm going to have clamps out here and stuff and all that. So I don't mind. I'm going to be doing some finish sanding anyways and everything. I don't mind little tabs on here. I'm going to clean those up. So we'll go ahead and add some tabs. My tabs don't need to be very big. They'll be 1/8 of an inch thick, 1/4 inch wide. And I'm just going to throw a tab here and here. And they'd be useless there. I'll go right here at the bottom. All right. And we'll calculate, this will be the profile cut. Left side. All right, calculate. Okay, preview the visible toolpath, and we'll have that cutout, and then we'll have the little tabs holding that cutout in, but that will be our leg, right? And again, we're cutting on the inside of the leg, so make sure your pretty face is face down. Okay? Pretty face is face down on the table because we're cutting on the inside of the leg for those cuts. All right? Awesome blossom. Cool beans. All right, let's move on. We'll do the right side. All right, right side Toolpath, same Toolpath. So rinse and repeat. We'll grab our 4 little squares right there, and the mortise for the shelf. Pocket cut, 1 inch thick. 3. This is going to be the through mortise right side. Calculate. Cool beans. Select our rectangle. Now watch how I select this, because that rectangle, you know, goes all the way around and we only have these 4 individual red squares here. I can just right to left, bottom to top, I can just drag my mouse through there and select those rectangles. Right, cool beans. And pocket cut, 1/2 inch deep. 1/4 inch end mill, everything's the same here. This is the blind mortise. Really good touch with this blind mortise, so that when those parts, those arch pieces fit in there together, from the leg of the table, that arch begins and ends at the leg. It's a nice design feature, a really, really nice design feature. It looks sharp. Okay. Blind mortise, right side. Calculate. Now, just real quick, let's say that you guys that are watching, that some of you don't have a CNC that you can do a 29 3/4 inch cut by 11 3/4. You know, you have a smaller CNC. Well, I mean, with a few marks and everything and a jigsaw or a hand saw, you can cut, you know, you can draw out on a board and you can cut a nice little angle there. You can measure and mark and lay out and cut a nice angle here and everything. You can even cut your tenons, and these here could be done with a drill bit if you need to. You would first, before you cut your tenons out, you know, hand saw, that kind of thing, you know, cut that out. You would actually drill, you'd mark where your drill, that'd be a 1/4 inch drill, right? You drill hole, drill hole, drill hole, drill hole, and then you would cut your tenon out with a jigsaw, hand saw, whatever. And then you could lay this on your CNC, and you could let the CNC do the joinery cuts. You know, you can lay on your CNC and do this first, you know, on whatever fits on your table there. Move the board down and cut this one out second. Create your Toolpaths to accommodate what you need to do for your machine. And the rest can be done and cut by hand if had to. No problem, right? So these, if you have a smaller CNC, these tables are not out of your reach, because these tables are using a combination of the CNC, but they're also using hand tools and table saws and skill saws and band saws and whatever you've got, right? You can still make these tables with the, you know, with hand tools and things too. Back in the day, before CNC, they chiseled these out with a chisel. But if I have a lot of mortises, like same thing the guy says in the video, if I have a lot of mortises that I got to do and stuff like that, I'm going to let the CNC do it, because, you know, that gets mundane, cutting out mortises with a chisel, you know. But, yeah. All right. So that takes care of the blind mortises. And then our final cut is our profile cut. Cutting 1 inch, 1/4 inch end mill on the outside of the cut. Profile cut, right side. Let's add tabs. And calculate. Okay, that takes care of the right side. Done and done. So there's our two sides. And again, you know, whatever you need to do to, you know, do it on your CNC. All right, our arches, they're just simple profile cuts. So profile cut on our arches. And on the arch, bear with me a second here. 1 inch thick, 1/4 inch end mill on the outside of the cut. On here and everything, I try to do my best to avoid putting tabs and arches and things where I could sand and mess up the arches and all. All I need is you know, a tab to hold these parts so they don't move, right? And so if I do put a tab on this, if I decided not to use double-sided tape or what have you, if I do put a tab on this, that tab would go here, because this joint is going to be inside the leg. It's going to be hidden, right? So when I sand that tab flush, that part's going to be glued into the, you know, into the leg all the way up to that line right there, right? You know, I could even throw a tab, you know, here if I wanted to on the ends. In this case, I'm going to throw one there and one down here. And over here, I'm going to do the same thing, one here and one here. Because again, on the end, I'm sanding that flush, remember, right? I'm sanding that flush anyway, so I can sand that tab away. Yeah, profile cut, preview the visible toolpath. Okay, now that tab on this part here, because this part, I made the part just big enough that, you know, my part barely fit on there, so it's going to be cutting loose here and here and here and here. I have a choice at this point. Now that I see this visibly, I have a choice. I either make my board just a little bit wider. I made it 7 inches. I go 7 1/4 or whatever, so it doesn't cut loose here and up at the top here. Or I add more tabs to hold all these parts together. In my case, I'm going to choose the latter. I'm going to go in here and instead of a, oops, on my sheet, on my arches, instead of a 7-inch board, I'm going to give myself a little bit of working room, working 9 to 5. Edit. I'm going to go 7.5. Oops. Hold on a second. It needs me to close this. Edit. 7.5. This one, edit. 7.5. I'm gluing them together or cutting them down to size anyway, so I can make a 7.5-inch board. All right, coming back in here, I'm going to take the part and center it onto the material. Wonderful. And on that Toolpath, I'm going to come in and I'm still going to put my tabs where I said I was going to put my tabs. I'm going to throw one here and one there. I'm going to throw one here and one there. Calculate. Cut out. Okay. Wonderful. Good job. All right, rinse and repeat. Center that on the board because I resized the board. Go back into the Toolpath that I was creating earlier. Edit my tabs. They're there. They're good. And calculate. This is going to be my arch. And it could be my arch left, right, because we're going to be specific. Calculate. Cool beans. All right. Now, the most important part. Not the most important part. The next part, sorry, is the stretcher. Then we'll get the table last. Stretcher. Profile cut. That's all it is. Profile cut. 1 inch. This is only 3/4 inch thick board. 3/4. On my tabs on this one, remember I'm going proud because I'm sanding flush, so my tabs are going to go at the end here. Right? I just need it to hold the part. Shelf board. Just need it to hold the part. Okay. And I'm going to make sure my clamps are here and here at the end of the table, not on the side, because that's going to get cut free pretty much, right? So make sure your clamps are at the end. Those tabs. Wonderful. Cool beans. All right, if you want to make your board a little wider, you can make your board a little wider, right? I went 7, I could go 7.5 since I'm doing all, since I'm doing all 7.5 on the 2 arches, and I'm gluing everything up, and I'm kind of in the mode. I got my table saw fence set at 7.5. When I'm cutting the board down for this one, instead of having to change it from 7.5 to 7, might as well go on in there and make this a 7.5 as well, so that when I'm cutting my boards down to their final size before they go on the CNC machine, I can be consistent, right? Think ahead, and life will be so much easier. All right, recalculate the board, and what that will do is that will simply just give us a little bit more room on the outer edges, all that good stuff, right? Cool beans. Okay. So, how y'all doing? Everybody hanging in there? Nobody's asleep yet, right? Wake up, wake up. Okay. We're almost there. We're at 9 o'clock. I'm going to try to get through those 2 tables, but really quickly, let's finish off this table fully. I'm going through this one fully. I went through a lot of explanation of how we, why we looked at and did our mortises and our T-bone fillets the way we did, and how I'll talk about which joints are going to get rounded off on the mortise. Or the tenon, and which joints are going to get round or squared off on the mortises. We'll do that in just a minute on the next 2 tables. But all right, now here, these are simple mortise cuts. Okay, we have these mortise cuts here, and they're going to be just a pocket cut. Now, how deep do we cut them? Right? Well, it's based on the height of our tenons on our side leg. right? So I believe it's a 1/2 inch, but let's take a measurement. From there to there, right? It's 3/4, not a 1/2 inch, 3/4, right? Now, we don't want to take the chance that, when that goes through, because it's a blind mortise. It means that, you're not going to see it through the top, because our table's 1 1/8 inch thick. We've got glue, right? We need some glue space, and we don't want to bottom out and then all of a sudden there'd be like an air gap where you can see through the top of the leg and under the table, right? We don't want that and everything. So our mortise for our tabletop, we're going to go just a little, we're going to give ourselves a little bit of room for glue, so we don't bottom out and get that fit, right? So we may give ourselves, 20 thousandths of an inch, 64th, whatever you want. I'm going to go, instead of 0.75, I'm going to go 0.77. I'll give myself that 20 thousandths of an inch. And that'll give me just a 0.02 amount of glue space on that edge, and I'll have a nice tight fit on the sides for plenty of holding power and all that good stuff. You can go shallower than that. That's totally up to you, right? We're just going 20 thousandths of an inch higher, more. So 1/4 inch end mill, and we're going to, this is the top mortise. Calculate. Now, these are going to be rounded. We're not going to square up the corners or anything on them. We're going to round off the tenons before we put the table together. If you want to, there's only 4 of them. If you wanted to square those off and leave the tenons round on the top of the sides, you can do that as well too. Just use a chisel and just chisel the corners in there. But in this case, we're going to just we're rounding off the tenons on all the other parts, so we're going to do it for this as well too. Now, when it comes to the 120 degree, 50 degree, chamfer, if you will, that undercut chamfer and everything was done on the table saw. But if I were to measure the offset distance, basically from here to here, it's 1 inch. Okay, so from that original end of my board, 1 inch back is where a vector line should be, or some kind of vector to create, that if I'm going to do the Toolpath in Vectric, I need that 1 inch vector line, right? Okay, so if I were doing that in here, basically, I'm going to draw a line here, and I'm going to select that line that I drew, and I'm going to move it relative to its position back 1 inch, -1 on the X to move it back 1 inch. And I'm going to mirror it, create a mirrored copy, flip about job center horizontally to the other side. Okie dokie, tokie dokie. All right. Now, if we're using the chamfer toolpath in this instance and everything, the arrows here the arrowheads point to the deepest part of the cut, right? We're cutting from the top down, and we're leaving about 1/8 of an inch reveal at the very bottom there. But the deepest part of the cut is where the arrowheads are. So it's starting up at the top and it's cutting down, and the deepest part is where the arrowheads are. So first of all, our start depth is going to be 0, and the bit choice is going to be kind of important, and most likely because it's such a long cut, if we were to measure that cut for a moment right here, it's 1 9/16. 1 9/16. 1 9/16. The overall, that length and everything. But we're actually cutting outward 1 inch. Which is 1 inch. Yeah. So the go back into here, and the cut. Let me do this. The cut is 50-degree angle. Okay, it's a 50-degree angle. And the that would be like 100-degree, V-bit or something like that, or whatever the case may be. So it's not 45, it's 50. They went 120 because they just did it on the table saw and everything. Instead of a 45-degree cut, they went a 50-degree cut, blah, blah, blah. If I'm using a 90-degree V-bit to do the chamfer, then I'm going to have, I'm going to end up with a 45-degree slope, right? If I'm using a 60-degree, then I'm going to end up with a 110-degree slope instead of 120-degree that they have in the drawing. You can make changes. It doesn't have to be exact. It's just a chamfer, right? It's a chamfer. Make it whatever you want. Whatever angle and everything that you want and everything. So it doesn't have to be exactly 120 is my whole point and everything. Brooks Martin says 50, 120. How do you get that? All right, let's go over here. Let's create a rectangle. Let's close this tool for a second. All right, if we look at their drawing, and let me zoom in. Hold on. Get it in the middle of the screen. Okay. So on the underside, making it an obtuse angle, it's 120 degrees, right? When we're cutting the other way, we're making it a acute angle, which is 50 degrees. So 120 degrees here and everything. So let's go back into Vectric. And if I take a guideline and 20. Bear with me. 120. Work with me there. Work with me. Okay. All righty. Move over to there. Okay. If I come in here, let's measure this. Angle measurement. From here, over to here, over to here. Okay. That's 130. It's a 60 degree. I keep saying, was I saying 50? 60 degrees. 60 degrees. So, bear with me. It's a 60 degree angle, not a 50 degree angle. 60 degree angle. Let's switch that back. 60. Oh, now I know why. Let's snap that there, delete that. Measure, angle, snap in the corner, stretch out to this leg, stretch up to this leg. 120 degrees, right? Okay. Now, on that 120 degrees, the equivalent of that is 50 degrees, right? Because I'm doing the chamfer. So I've got to move this. Oops, close that. I've got to basically move this cut into, you know, the position to do my chamfer cut, you know, that underground chamfer. It's a 60-degree cut, not a 50. 50 is 130 degrees. Sorry, guys and girls, the whole time, this whole video, I was saying 50 degrees, 50 degrees, 50 degrees. It's a 60 degrees or 120 for a total of 180. 60, 20, 180, right? Cool. Should have done my math in my head a little bit better. So, we are doing a 60-degree angle cut over the span of 1 inch. Now, that's a 120 degree. I could come in with my chamfer toolpath and I could say, oops, let's change this. My cut width is going to be 1 inch. Okay. And my cut depth, 1.7325, right? The cut depth on my 1 1/8 inch thick board, right? The 1 1/8 inch thick board. I need to change my bit, by the way. All right. My width. I am bound by whatever bit I use. When my width and my height, those are the two numbers that I can change. Okay. And my cut depth, I'm cutting down. Let's come here. The cut depth I'm cutting to is 1 inch deep, right? I'm leaving that 1/8 of an inch reveal, this part here, 1/8 inch, right there. I'm leaving that. So I'm cutting down, my depth is 1/8. And the overall, you know, from here to here is 1 9/16, you know, overall, and all that good stuff. But straight across, it's 1 inch over, 1 inch down. So come back in here. On my chamfer toolpath, my cut depth, I'm cutting 1 inch. Okay. Now, it's automatically calculating my width. You know, it's all based on, you know, the bit and the angle and all that good jazz and all that stuff. And that 1 9/16 and everything, the numbers with my, you know, 120 degree V-bit, they don't match out, right? Because my width is only straight across, that width, it's only 1 inch, so 1 inch wide, cut. And I want to cut 1 inch down, right? But the numbers don't jive with the bit that I've chosen. So I'm going to select a ball nose bit. My 1/4 inch ball nose bit. And the angle, I'm going to be going at an angle of 60 degrees. I'm going to be cutting 1 inch over. Let's go 120. 1 inch over. And the cut depth is still showing my cut depth is 0.5, right? I'm going to go 1 inch deep. I'm going to, I want to be cutting from here to the deepest part of the cut, which is there. I'm going to calculate that tool path. So let's go 60. Yeah, it's not, the chamfer toolpath is not giving me the options that I want, you know, and it's not giving me the step over that I want and everything. All right, let's do it this way. Let's do it this way. I'm going to change things up a little bit. I'm going to go with a 90-degree V-bit. I'm going to cut over 1 inch and down 1 inch with that 90-degree V-bit. I'm going to calculate that to create that undercut. I'm going to do the same thing on the other side. And the final profile cut, if I was using a CNC to do all this, but again, table saw, right? And it's a 60-degree angle on your table saw, not a 50, 60-degree angle. So everywhere I said 50 throughout this whole video, it meant to say 60. Sorry, guys. I was on a roll too. I was good all the way up into there. But profile top. Dadgummit. Okay, so that'll give us that chamfer to that angled top there with that 1/8 of an inch reveal. So use a 90-degree V-bit, go 1 inch down, 1 inch over, and that'll give you a good result there too as well, using the chamfer toolpath. Yes, Michael, it is. And Michael's asking in that chamfer if I use a 60-degree. To achieve the required 1 and 1. Yeah, it's... Oh, hold on a second. Yeah, it's going to be one or the other. If I go 1 inch over, it's only going to go a 1/2 inch down. And it would look something like that. Right? So I can't get it to go over that length and that down to that depth at that with that angle. The 90 let me work it on a 45, 1 and 1. But the chamfer toolpath isn't giving me the ability to make the 1 and 1 cut. So it's kind of restricting me and everything. So with that bit, it tells me the maximum cut depth I can do. So with the 90-degree V-bit, you know, my maximum cut depth, I can cut 1 inch, which is what I want to achieve. Okay. So if I was doing it on the CNC, right? And that would give you those, you know, that recess cut. Or it's a 60-degree cut on the table saw. Okay, so that's the top. Now it's 9:29. We're going to try to, don't know if I'm going to get the other tree. We waste so much time on that one. All right, let's come in here and file save as. This is our haul table. Haul table. Let's go ahead and file open or file new. And 18 by 36 by 1 inch. We're going to import. I want to show this Lambert Cafe inspired table because the way the cuts were done on the inside cuts, you'll see here in just a minute, how he, instead of doing tabs and stuff, what he did in the video. I want to have a discussion about that. Let's import the files. So we've got our lower stretcher. We've got the side. I'm going to hit G on the keyboard to group that together so none of that stuff gets moved. We've got the top. Top has just a little bit of a flare to it on the 4 sides. They're not straight. Just a little bit of flare. And then the upper stretcher. And the upper stretcher has a shoulder cut. We'll look at that in SketchUp here. All right, let's get the side on. I'm going to rotate this, and I'm going to hold down the control key and drag a second one here. But I want to get this centered on the board. And this side here is 29 inches by 22 inches, okay? So on the material, I'm going to actually lay out a piece of material that is going to be, I'm going to go 30 by 24 by 1 inch thick. And let's get that centered on the board. Okay, now these cuts here, let's U for ungroup. U for ungroup. These cuts here on the side, these squares, these are just through cuts. They are just decorative. So they are just decorative through cuts and everything. So let's zoom out so you can see the table in its entirety, the assemble up here in this ISO view. Let's zoom in. Okay. And in SketchUp, if we come over here, let's hide all of that. And let's take a look at this. Now, I'm going to explode this in SketchUp so that I can move the lid or hide the lid. And I want to talk about these stretchers, these shoulders that were cut. On these stretchers, I'm going to move one up. And I'm going to change the color of it so that it's a little easier visibly to see. See what shows up in the video better. Okay. Let me turn this up here. All right. Let's hide this out of our way. All right. So in the video, you're going to see that he did a shoulder cut. These stretchers are 1 inch thick. The side mortises here, the side mortises on the sides are 5/8 of an inch thick. Or I'm sorry, 3/4. Okay. So that calls for a bit of a shoulder cut so that it fits in. Now, in the video, he did not want to do a two-sided job where you have to flip the board over. So he only did the shoulder on one side. Now, I didn't know this. I assumed automatically because 1 inch part, 3/4 inch slot. I need a shoulder on it. You know, the design showed a shoulder in the vector that came in. So when we're looking at the vector, it had the vectors for the shoulder. Okay. I did not assume that the shoulder would be cut just on one side. You know, when I'm using hand tools and stuff, I would cut the shoulder on both sides of the board so that when the joint went together and everything, we had that, bear with me a second. When that joint went together and all, we had that shoulder cut on both sides. Well, I assumed wrong. He did the shoulder cut on the inside only. So the shoulder cut, the full shoulder cut was cut on the inside so that he didn't have to flip the board over to do a two-sided job. It didn't have to turn it into a two-sided job to put shoulders on both sides because he was using the CNC to cut this. So he did it just on one side. So what that looks like is, let me move this back up. In here, oops, wrong side, hold on. Flip over here. And over here, he went the full 1 inch, 3/4, so a 1/4 inch there. And when the part went in, this is what it looked like from the outside. You don't see the, you don't see the shoulder cuts anyway, in the joinery and stuff. The shoulder cut was only on the inside, that 1/4 of an inch. Fine. He did it on the inside for both parts. In my drawings, as you can see here, my parts are mirrors of one another, so it copied this one over. Let me move this one up. Move up. Okay, so versus doing the shoulder cut on the outside. He did it on the inside, a 1/4 inch deep. I went an 1/8 inch and an 1/8 inch on both sides because that's how I would normally do the joint if I was doing it by hand. But that it was the wrong assumption. He made it easy. So the whole point of all that is if I was doing this table by hand, it would have gotten a shoulder on both sides for the joint. However, I'm carving on a CNC. So as he explained in the video, to eliminate having to flip the part and re-register it and reset it up and all that, and you know, cut that other piece and everything, the other side, just do the shoulder on one side and put the shoulder on the inside, so it's not going to be seen anyway, but it's more concealed. Okay, which makes sense. All right, so when we go to lay out this part, this joint here is going to be a 1/4 inch deep, and it's going to be just on the one side. Now, notice that there's a little bit of a relief here. Okay, a little bit of a relief here. Well, there's a reason for that relief. It's all done by design. That relief there, what's going to happen is, let's go back to SketchUp. Let's take this part and move it. When this part here gets cut, there's going to be those fillets. And give me just a second here. It would help if I would have done that. Give me just a moment. Now this one's going to be screwed up because I put the circle in the wrong place. Give me just a second. Okay. When we cut this joint, we're going to put our T-bone fillets into this mortise cut here, so it'll look like this and everything. And because of that 1/8 inch and all, when our part goes together, work with me, work with me. Come on now. Go down, go down. I hate when it doesn't want to cooperate. Beautiful. Okay, finally. Well, anyway, when those parts fit together, I'm going to try to move this straight up. When this part goes together, it's going to conceal and hide those fillets. That's what that relief, come on now, pull out here. That's what that relief is for in the bottom of that cut. Okay? Smart thinking is very smart. So the instructor on the base camp and all, he really thought about the design when he laid everything out and all. One, not having to flip the parts, you know, for a two-sided job. Two, the fillets that we create, how they are going to be hidden by the joinery and not seen, so they won't be exposed in ugly eyesores and things, and all of these things. So everything was laid out. When they thought about it, they thought about it, you know, very smartly, right? And that's what we need to do when we're creating projects and all, is think ahead, think about joinery, think about, you know, how our parts are going to fit together, and if, you know, things are going to be exposed or seen or hidden or whatever the case may be. Do we have to do a little bit of handwork? Do we have to round the edges so it flits in the square peg, you know, and that kind of thing, or, you know, the round mortise and all that stuff. You know, after the CNC, you know, the CNC can do so much, but there's going to be some things that we have to touch up to get that fit. And that little detail to hide those fillets that are going to be required for this cut here, to get that nice flat bottom there, that part, the stretcher hiding it, good touch, great touch. Now, on this part here, the through tenon on the bottom stretcher, the tenon comes all the way through, it's going to be exposed. He took a little block plane and did a 45-degree little chamfer with his little block plane on each edge just to give it a decorative touch. So I had a nice little chamfer on the edges and all. But he rounded the 4 points of the tenon so it fit into that mortise on this one. Okay, so I had rounded edges, but I had that nice little 45-degree chamfer, and it looks good. You can see the end results in the video and stuff and everything. So for us, we're simply going to, here on our parts, it's just a profile cut. The only thing that we need for this side piece are the two fillets. So we're going to come into our fillet tool, 1/8 inch T-bone fillet. And remember, you want to click on the line where that T-bone fillet is going to go. Remember what side of the line you click on. We're coming straight down on that. Okay. Cool beans. All right. No other fillets or anything are needed for anything else. Now, here's something else that he did. It's not in the design here, but he says it in the video. And if you pay attention to the video, he explains it when he's showing the cut. But he had the CNC come into the center of these holes and drill a hole into the center of these blocks. Now, I'm going to size these holes and everything. Give me just one moment. Size tool, I want to size them individually. And I'm going to go an 1/8 of an inch. Same thing here. Size individually, 1/8 of an inch. Now I want to center these up, so I'm going to do one by one. I'm going to select this one. I'm going to select the rectangle last and align to that last item I want to center, right? So select the circle first, rectangle last, align to center. Circle first, rectangle last, align to center. We're aligning to selection. We're using the align to selection option, center. Okay. Now, those vectors weren't in the design, but again, in the video, he explains what he did. And here's why these circles are here. He had the CNC drill a hole through the piece, and then he took a screw and he screwed through that hole down into the wasteboard. He put a screw in each one of these holes to hold these parts from moving. He screwed each one, And then he did a profile cut on the inside of the line to cut out the profile without any tabs. So he didn't have to put any tabs. He didn't have to worry about the part shifting and breaking the bit or anything when it's cutting out or anything like that. He just screwed the parts down. And I don't mind that in the wasteboard. I mean, that's what it's for and all that. But he had the... And how deep he drilled the holes? Well, most 1/8" bits, if you have, just an 1/8" bit off the shelf, it has a, a 1/2" cutting flute. He probably went that far. But if you get like a speed tool from Amazon, speed tool is a good bit. Speed tool has a extra long 1/4" shank, 1/8" diameter bit that has a 1" cutting flute, right? Speed tool does. It's a really good bit. SPETOOLS, speed tool. But on Amazon, it's called an extra long 1/8" bit with a 1/4" shank, 1" cutting flute. 2 flute, up cut, down cut, or compression cut, right? Now, I'm okay with that. I think it's a good idea because the last thing I'd want is, my bit to be cutting these inside cuts and that piece shift, jam my bit up, break my bit, anything like that. I'd much rather have the part held down. I don't want to have tabs. I don't want to try to put double-side tape and, make sure it lands in the right areas and all that stuff. So having the holes drilled before the profile cut's done, having the holes drilled first, drilling Toolpath. In this case, I'm going to go 0.8 inches deep because I have the 1" cutting flute. I don't want to go all the way through up to my shank, so I'll just go 0.8. I'm going to use my 1/8" end mill. And I'm going to peck to the cut, but I'm going to calculate that toolpath. And that's going to drill those holes and everything. Then I can put my screws in. And then I'll do my profile cuts. On the, I'm going to go all the way through 1 inch. I'm going to go, I can use my 1/4" end mill for that. And I want to be on the inside of the cut. And this is my side cutouts. Preview that toolpath. Now this part here, I'm not really too worried about. It's not a really big piece and everything and all. I'm not really worried about that. If I am, then I can do that one as a pocket cut while I do the profile on these. And that's what he did. He did it as a pocket cut on that inside one. Let me take that one out of the equation. Let me take that one out of the equation and calculate that because I don't have to change bits or anything. It's just as easy for me to create a pocket cut, cutting 1 inch deep with my 1/4" end mill on this part. And that way I don't have to worry about that little piece. But these will be screwed down. I don't have to have tabs or anything like that. And very nice. And they're for decorative purposes. There's nothing getting used there and all. We're going to do a profile cut on this. Profile cutout. 1 inch thick material. So I'm going to cut on the outside of the line with my 1/4" end mill. Tabs. Again, I can add some tabs if I need to hold the part in place. Calculate, profile cutout, profile cut out sides, side. Okay. Now, on this, oops, undo last. on this cutout and everything here, really, I don't necessarily need to create a board for the left side and right side as far as in the drawing. I just need to run this toolpath twice. And I just need to make sure that, because it is a through mortise, it's not a shallow mortise at all. So I could have my pretty face facing up. In the instance of this, I could have my pretty face facing down. But I just have to know one side's going to be my left side, one side's going to be my right side, right? So one side facing up, one side facing down. Just know your faces, right? Know your faces and what side's going to be out and everything. Now, if I wanted to, I could, just create another sheet just so I have the drawing all together and everything. I could just run these toolpaths twice, right? Simple enough. Or I could go in and I could create a second sheet, and I could move that to sheet 2. And on sheet 2, I can center it, align to center. Okay. And then create the same toolpaths. For the stretcher and the shelf, the stretcher is 1 inch thick. 1 inch thick. The shelf here, this guy, the stretcher, it's vertical. And it is 3/4 of an inch thick, this board here, right? So I need to create another sheet. And this will be my stretcher, lower stretcher. You guys still with me? Wake up. All right. And Troy asked the question, why not pocket them out? You can pocket them out. It just the toolpath takes longer. He has set these toolpaths up so that even though they are elegant looking tables, he's creating it like a production part. So the faster toolpath is going to be the profile cut over the pocket. Okay, and that's how he explains it in the video. So he's running the parts, even though they're elegant tables and everything, he's running them and setting up the toolpaths and everything as a production part. Don't want to have to flip the sides, for a 2-sided job. That's why, he did the one side and he did the shoulder on the one side and things like that. That's why he is not doing all the exposed fillets and all. He's wants it to look like an elegant piece, but he also, what's faster? It's going to be faster for him to round over those edges to, for the joiner to go together and stuff by hand and things like that. So that's why it's a profile cut versus a pocket, but you could absolutely do a pocket, Troy. Yes. Lower stretcher. The lower stretcher, the board's going to be, 28 inches by 8 inches. And of course, let me put that back because that was not the right one. I didn't change the right one. 30, 24. Okay, lower stretcher, edit. You son of a gun. Lower stretcher, edit. There we go. 28 inches by 8 inches by 3/4. Okay. All right. And we'll take our lower stretcher. We'll move that to the lower stretcher sheet. And on that sheet, we'll center that part. Okay. This is just going to be a profile cut. And again, it's going to be a through mortise, right? So we want our fillets on this part to be hidden when it goes into that part, our T-bone fillets. We want to click on this line. We want the fillets going inward. Okay, inward. There you go. That'll be that, and it's a profile cut. Cutting 3/4 of an inch deep, 1/4 inch end mill on the outside of the line. We'll add tabs, and now let's stop here. Let's stop. I want to give my, no, this is a through tenon, so it's already designed to be a through tenon, so I don't need to add any extra to it. So I can go ahead and just calculate that. Let me get my tabs in there. I don't want to put tabs on the end because it's the through tenon and all, and it's going to be exposed. Even though I am going to sand and clean up the end, I don't want to deal with that. So I'm going to put the tab, close to where, it's going into my board. My board is 1 inch thick, so anywhere right in there is fine on my tabs. Because I can just run a chisel and then I can glue that piece in and good. Okay. Calculate. So tab placement, if you're going to use tabs, fillet placement, all these things you think ahead, think about. All right, let's preview the visible toolpath. Wonderful, there's our part. The lid is just the lid and the stretcher's the stretcher. Let's get the stretcher first. Come on now. All right, that stretcher is a new sheet. And we need 2 of them. 2 of them. So, a new sheet. Upper stretcher. We're going to edit that. It's going to be 35 inches. You can go 36. I'll just go 35 because it's only 33 the part is. By that stretcher's 3.5 inches tall. So 3.5, 3.5 is 7. 8 is good. Click, and it's 1 inch thick. 1 inch thick. Okay, on that stretcher, I know it's 10 o'clock, guys. You're getting tired. Everybody's getting tired. We'll just do the stretcher. I think you can kind of figure out the toolpath for cutting the lid out, right? Let's move the stretcher to that sheet. And let's center that part onto the material. Okay. Now, how big did I make that sheet? Ooh. 8 inches? I don't look like 8 inches, does it? I swear it's 8 inches. Okay. Let's mirror this part. Drawing, mirror, flip. Oops. Okay, now on these shoulders and everything, on the shoulders here, since they're going to be cut out, we have our, they're going to be cut on the inside. Okay, so when these are side by side, the shoulders cut's going to be on the inside. So instead of, on this vector here, instead of just one rectangle there, we're going to make things easier for us. We're going to go ahead and we're going to draw a rectangle across our board here. Like that. And over here as well. Oh, a little shy on that one. There. And the shoulder cut, when this profile gets cut, right? Let's deal with the shoulders first. So we're going to do a pocket cut. We're going to grab this and that. And that pocket cut is going to be 1/4 of an inch. Remember, 1 inch thick piece, 3/4 inch slots. We need 1/4 of an inch for that shoulder. And so we're going to go 1/4 of an inch and 1/4 inch end mill. This is going to be our shoulder pocket. Shoulder pocket. Calculate. Preview that visible toolpath. So that'll cut the pockets across the boards here. All right. Then on the profile cut, okay, notice that the profile, he has this piece, right, which is, separate from the rest. It's not one continuous profile. So in the vector, we need to, and I'm going to move these two rectangles just for a minute. I know where they go. I can put them back, but I'm going to move them for a second. And the reason why, as it's separate, because they have that rectangle, this rectangle, and then this, right? But they don't have, there's not a profile for the final profile cutout, okay? And that's what we're missing, So we're going to take these 3 parts, since we have our 2 rectangles that are going to create that shoulder, we're going to take these parts and weld them together. The weld worked over here, but it didn't work over here because we didn't have enough of an overlap. So I'm going to undo that weld, and I'm going to take this rectangle, hold down that shift key, and I'm just going to stretch it a little bit. Right? Stretch it a little bit. Okay. That way it gives me some really good overlap. And now I should be able to weld those parts to get rid of that overlap. Right? So same thing here. I'm going to take this rectangle, stretch it, hold down that shift key so it stretches in both directions. Same thing here. Stretch in both directions and weld the 3 parts together. Weld. All right. And then you can put your, we can put our rectangles back here for our pocket cut in just a minute. I don't want to do that quite yet, because remember now, when that profile cut comes and cuts, that 1/4 inch end mill, we've talked about this throughout the whole night tonight, right? So when that 1/4 inch end mill comes in and cuts and everything, we have to, create that fillet, right? And our fillet, we're going to go upward here because it's going to be hidden by that that joinery and everything. Remember, so we need to take our fillet tool, make sure we're clicking on the right side of the line. Okay. Now, if we go back into SketchUp here, those fillets, if I were to move this part up, those fillets are going to be in here, right? And when that joint is together, you don't see in there, right? It's concealed. It's hidden. Great, great job, right? If your video is blurry, John Thompson, you have a little gear icon at the bottom of your window. Change your settings. So I'm filming in 4K, 1080p, is what YouTube is running at. So you need to change your settings. You're probably setting a low setting. Click your gear and that'll tighten it up for you. That'll get rid of the blur. John Thompson. All right, let's go back here. And so now that you understand that those fillets are going to be hidden, right? But they're necessary, they're required for that profile cut. Now we can put our rectangles back. Okay. All right, so our shoulder pockets are done. Now we just need our profile cut. Cutting 1 inch deep, 1/4 inch end mill on the outside of the cut. On this one, I don't want tabs. They're not going to do me any good on the outside here or here. Okay. So what I'm going to do is I'm going to use his trick. And this inside area right here is all concealed when the joinery goes together. I'm going to drill a hole. So the pocket cut will get cut first. The next cut will be these holes getting drilled. And then the final cut will be the profile cut. So I can put screws in there to hold those parts down. Screw there, screw there, screw there, screw there. And then I can do the profile cut, cutting 1 inch deep outside of the cut. I don't need tabs for this. And this is my upper stretcher profile cut. Calculate. Preview the visible toolpath. Right? And that way, then I can unscrew those parts and everything's golden. Right? Good. Okay. And again, I think you guys can handle cutting out the top, right? It's a profile toolpath. Let's move on. 10, 12. How many want to see the round table, talk about that, or do we do that in another class? It doesn't all have to be done tonight. We can do it in the next week or so. It's up to you because that one is going to be pretty self-explanatory. It's only straight cuts and mortise cuts and everything. And you want to have that discussion real quick. It'll take about 15 to 20 minutes. So we'll end about 10:30. 10:30. Let me know. File, save as. This is going to be the Limbert Cafe inspired table. All right. And let's create a new. Okay, go 24 by 24. All right, so let's do the last table and then we'll wrap it up. Here we go. The last table is our round table. So let me zoom out. Okay, not that far out. All right, so our round table. So this table features through tenons. Let me come over here. Actually, let me just go into the SketchUp. Edit. Unhide all. Let's take a round table. Let's move that over there. Let's take these guys and hide them. All right. So let's take a look at this. Let's hide this. Hide this. Okay. So let's explode this a little bit. Let's move this one out this way. This one out that way. This one, oops. Here. This one there. And let's take this one and move it up. Up, straight up, alternate, up. There we go. Okay, and let's take this one. Move it down. Okay, now, here's my mistake in my drawing, okay? In my drawing, I assumed that all of the parts for the frame were 1 inch thick, okay? But that was not the case. These parts here were actually 5/8 of an inch thick. The upper parts were 5/8 of an inch thick, so that it go there, go there. Let me get rid of this line. This, oh, I'll change the color in just 1 second so you can see things a little clearer. Delete, delete, delete. Switch around. Push and pull, that goes into there, that goes into there. Select that line and hit delete, that line hit delete, that line hit delete, and that line hit delete. And let's change the color to something a little bit lighter that makes it a little easier to see. Okay. All right. So because the mortises are 5/8 of an inch thick here, these inner pieces are 5/8 of an inch thick. And what this does, and all 4 inner pieces, I just changed the one, but all 4 pieces are going to be cut out of 5/8 inch thick material. And what this is going to do, it's going to give us that heavy versus light appeal. If all the parts were 1 inch thick and our mortises were 5/8, we would have to do some shoulders on one or both sides of the cut, right? If you didn't want it to be a two-sided job. But again, didn't have any instructions, didn't have any details to it. So I assumed that there were shoulder cuts on one of the parts so that when the parts went together, you know, everything fit nice and pretty, right? But no shoulder cuts needed on these parts. They're just 5/8 of an inch thick. And that's going to give that light appeal where you have your heavier woods for your legs and your tabletop. And then your smaller pieces, your shelf's going to be a 1/2 inch thick. That gives a little bit of dimension to the table. The top table where, you know, everything is going to be set, you know, is going to be a little heavier. That little shelf is a little bit thinner to give a little bit of demure to it and everything. And then our stretchers are smaller in size as far as thickness, just to give a little bit of consistency. So the elegance of that look, and it's hard to tell when it's all kind of monocolor and all, but just really good appeal. So for us, on our round table, we're going to import, this one should be very quick here. We're going to go to the round table. We're going to import our leg. We're going to import our lower stretcher mate. Move that. We're going to import our upper stretcher or lower stretcher. Okay, so there's pairs. We're going to import our shelf. We're going to import our top. We're going to import our upper stretcher mate. And our upper stretcher. Now, one of the things that you'll notice, you should notice right away, is that the upper stretcher, here, the upper stretcher, the tenon is offset, while the lower stretcher, the tenon is centered. That offset gives a little bit more, from the top of the board and all, when that tenon goes in, it gives us a little bit more meat here. If we were to center that tenon on there, then we would have a very thin piece of meat right here, and could make it a fragile point in the table, you know, a breaking point and stuff. So it is offset and lowered down and everything. You know, when these parts and everything, if I were to line up these parts really quickly, I'm going to select all 4 of these parts, and I'm going to align them left to right with one another. Okay, so they're centered here and everything. And I want to take this and I want to center this on the board. Okay, I want to center this on the board and everything. All right, and then I want to take, and this board is currently, my material is 24 by 24 here. I want to take a guideline. I want to take a guideline here, and I want to move it over. I want to create a relative guide 12 inches over. 12 inches, create the guide. Okay, and I want you to notice something. Okay, the parts, the tenons, the way the joint fits and everything, they're off centered. That's not by design. That's incorrect. When these parts, imagine one part turned 90 degrees and the other, when they fit together, we need equal amount of spacing, you know, on all 4 sides and everything, because it's a round table. So we have an equal amount of spacing. For the distance between the inside of this leg and this leg, the distance between this leg and this leg are the same. So we need our parts, when they come together, we need that tenon to be in the center of the part, not off-center. Because if it's off-center, then that's going to shift everything to one side or the other, right? So that was the only mistake that I found in the drawings. Okay? That's the only mistake that I found was for the drawing, in the drawings, of all the drawings, was that these tenons were off-center. So we got to do a quick repair. That's going to consist of some node editing. Okay, and then some joining, right? So what we're going to do is, let's start up at the top and we'll just work our way down. We're going to select on this vector here. We're going to go to node editing. We're going to cut the vector here. We're going to cut the vector here, and we're going to simply move, grab this right at the center of its point, and we're simply going to move it over to the center. Okay, my parts are centered on my board left to right. I've got a center line for reference, so all I have to do is reference the line with the center. Okay, and everything and all that good jazz and all that good stuff, right? So if I grab it in the center here, I can snap to that center part there, right? Now we're going to take our stretcher. This is the top leg. We're just going to join with a straight line. Join with a straight line to close that up. And with our scissors, we should be able to just trim that to create that new part. Right? Simple enough. Now, the lower part has an arch. It's a little bit different. Same scenario. We're going to take this. We're going to cut the vector here. We're going to cut the vector here. Get out of node editing. We're going to grab this part right in its center mark and snap it to that line. And here with the arch, we're going to join with a smooth curve to finish that arch off. And if we look, we're extended over the line here, but if we look here, we're short of the line. So we can't just do a nice little trim with our scissors because it won't trim properly because that leg is short. So we're going to go into node editing, and we're simply going to select these nodes. I'm going to use the down arrow key on the keyboard just to bump them down past that line. And then I can use the scissors to trim those two to get that center. Good to go? Good to go, everybody? Good, good, good. All right, rinse and repeat. Node editing. Cut the vector, right click. Cut it there on that node, cut it on that node. Get your mouse right on the nodes. Get out of node editing. When you click, there's an automatic center to this line. When your mouse is over it, you'll get a diagonal slash there. Drag it straight across. Snap it to that guideline. Come up here. This is a straight line, not an arch, so join with a straight line, and we can take our scissor and just trim there. Simple enough, quick fix. Okay, same thing over here. Node editing. Cut the vector here. Cut it here. Get out of node editing. Double click, grab it in the center, on its center point, and just slide it over to the line. Join this. This is an arc. Join with a smooth curve. Get into node editing and select on this piece again. Grab those two nodes. Use your down arrow. Just bump them down a little bit. And then take your scissors in and trim, trim, trim. All right. That repairs our parts. That's it. Okay. Done. You can get rid of your guidelines and everything. So that was the only issue that I found on those parts. Okay. Now, when one part fits over another and everything, they're hidden, and all we have profile cuts on this. So again, hidden joinery, our profile cuts, those internal corners, we have to put a fillet on them so we don't get arcs and everything there and all that stuff. And so on each one of these parts, they're going to have a T-bone fillet, and they're going to be, on this one, it's going to be pointing down. This one's going to be up. When those two fit together, these ends will cover here, you know, and it'll hide those. Same thing here. Down, down, up, up. All right, that's that. On our joinery here, we only have one inside cut right there, and we want to make sure the tenon's going in. Okay, in, 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 in. And here we have two sides, two inside corners. So in and in and in. All right, so that is going to be our 4 cuts for our stretchers. Now, these stretchers, we really only need 21 by 16. So let's go into our job size here, sheet 1, and let's edit that up. And 21. I'm going to go 24 on the width, and I'm just going to go 16. And these are 5/8 of an inch thick. Okay, I'm going to center those onto the board. And they're a simple profile cut. Okay, so this one was easy. Just needed the fillets, had to fix it. We had to fix it, but easy enough. We just have to put our fillets on it, and then I got our profile cuts, okay? Now, again, 0.625 thick cut. We're going to use a 1/4 inch end mill on the outside of the line. If you are going to do tabs on this, if you're going to do tabs, hide the tabs on the tenons. Now, these are through tenons, so make sure you're close to the joinery because it's only 1 inch thick, right? So if I, just as an example, if I came in here and I moved that out or created a relative guide 1 inch over, okay, this much of the tenon is going to be exposed now. So anywhere in here, we can put a tab, right? You know, on the bottom and the top side. It'll be hidden when we sand and stuff. So that way you don't have tabs or to deal with tabs or any of that stuff out here and all. Now, also the top of these parts, you know, when they're together, there's going to be a shelf sitting on them, right? And screwed to it. You're going to be screwing the shelf into there. So you can put tabs on the top side, on the flat sides, not the arch sides, if you have to, and everything and all. Okay, right? So let's go here. Let's go add tabs. And I'm going to throw a tab there. All right, and that's really all the tabs that I kind of need. I mean, if I was feeling insecure or whatever, if I was going to put another tab in there, then I would put one at on the flats. You know, just one, right? Your call. That's going to be covered by a table, remember? Don't get out here because the table, the lower one, the table's only 14 inches and the top one's going to fully cover. All right, so we're cutting all the way through on those parts and cutting them out, right? And there's our parts ready for assembly, sanding, cleaning, assembly. Now, what they did in the video is they chamfered, they rounded off they left these square on the round table. They just squared off the legs. We're going to talk about that in just a second. But on the exposed corners, they did a little chamfer on the 4 ends and everything, little chamfer with a little block plane and all, just to give it a decorative look and everything. But they did not round off these corners. They did not round off these corners on these tenons. They left them square. Okay, you'll see that in the video. Now, the table legs. We need 4 of these. So hold down that control key and drag out 1, 2, 3, 4. And these table legs are 28 inches tall, roughly. And so we're going to go with another board, another sheet, new sheet. We're going to go 28. I'm going to go 30 inches. Oh, hold on. That's my name, legs. On the legs, I'm going to go 30 inches by 16, and the legs are 1 inch thick. All right, you guys still with me? We're almost there. We only have 2 more things to do. We're going to take our legs, all of our legs, and we're going to move them to the legs sheet, make that sheet active, and we're going to rotate. I'm going to hit the number 0 key, oops, to rotate, and I'm going to center them onto the board, and I'm going to group each of these individual pieces together, right? I'm going to group, 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 group. I'm going to draw a rectangle around my board here. And the reason why I group these together is because I'm going to grab these 4 groups, select that rectangle I just drew last, and I want to space equal distance inside of that and center them, spacing them equal distance. All right, I had one part that was not grouped properly. So let me go in there and fix that. G for group. There we go. All right, one more time. Select that. Select the outside rectangle. Center them and then space horizontally. And there, right? So it fits on my part. Now, the closer tenon here, that's the top. The longer tenon, that's the bottom. That's the bottom of the foot. Now, they chamfered with a block plane. They ran a block plane on all four, once the parts were cut out, on all four edges to give a little bit of a chamfer, a little 45-degree chamfer, on all four sides of the legs, the edges, and on the feet. On the feet. So, and generally you would want to chamfer the feet so that they're not sitting, so that you don't get any wobble in the legs. You want to kind of give a little bit of a relief cut on the feet. So they're sitting kind of on that center pad and everything. And, but they did all four sides, not the tops, just the sides, all four face edges and the bottom of the feet they chamfered. Now, they did not do any chamfering or any fillets or anything on the legs. Straight up profile cut on here, going 1 inch thick, 3/4 of an inch. Calculate. Let's throw some tabs in here. The tops are going to get covered by a tabletop. And the bottoms are going to be the feet. I don't want to sand the, let me undo, oops, hold on. I don't want to do that. I don't want to put them on the feet. I don't want to put them on the feet. I don't want to sand the feet. I don't want to screw up making a wobbly table. I don't even know why I even put them there. I'll go ahead and throw a tab there. There. I don't want to put them on the top there because I don't want my top being wobbly. All right, let's go ahead and calculate that. Preview the visible toolpath. Okay, now on these parts, you're going to need a corner chisel or a chisel, but, and bear with me just a second. Bear with me just a second. Do you see how big that cut was right there? That looks like, it looked much bigger than a 5/8 of an inch mortise, right? Well, that's because on that profile cut that I just calculated, my outer rectangle that I drew was selected. That bad boy needs to be deleted. It don't need to be there no more. I just used it to sort these out. But let's redo that. That looks more appropriate there. Lord have mercy. On these mortises, you're going to take a chisel and you're simply going to just sharpen up these corners. You're going to take a chisel and chisel away the four corners and you're going to square them up. So this is the only one, this is the only table where they squared the mortises instead of rounding off the edges and everything. Just because they want the tenons, those through tenons, they want nice square tenons for that look. It kind of gives it the look, almost kind of gives it the green and green kind of cushion look almost. But we're going to square these up. So you're going to have some chisel work on this. You're going to square up those inside corners so that your joinery fits together. When you watch that video, you'll see that. Now that video is not long. It's only it's not too long. It's only 30 minutes, an hour, something. I'm not sure, but it's a good video to watch. And again, the link to that whole article and video and everything for episode 14 of Woodsmith and the 3 arts and crafts tables is in the description of this video. All right, so that only leaves the lower shelf and the upper shelf. So let's create our sheets. We need a sheet for the lower shelf. The lower shelf is only 14 inches in diameter. So this is going to be the lower shelf. And the lower shelf, I'm just going to glue up a panel that's about, 15 by 15, 16 by 16, whatever you want to do. And it's going to be a 1/2 inch thick. 1/2 inch thick. It gives it that demureness to it, that it takes away the emphasis of the, it just gives that definition. The tabletop is a 1 inch thick, and the shelf is a 1/2 inch thick. All right, let's go into here. Our shelf is going to be moved to the lower shelf. Move to lower shelf. There we go. I think that's pretty much explanatory as far as the cut, right? It's going to be a profile cut. Now, on this one, particularly, 16 by 16, I might throw some double-side tape down and everything, so I don't have to deal with any tabs and sanding and stuff on this. I just want to be able to cut it out, clean up the edges lightly. I don't want to have to do any crazy stuff, but you can put tabs on there if you want. You're sanding them away anyway. That's totally up to you. As far as what you're going to do with the, that 1/4 inch end mill, cut that out. Okay. So that'll be our lower shelf. Now, when you put the parts together, and you'll see watch the video for the assembly. He gives a good instruction on the assembly. They really go over the assembly really well. Basically, the lower shelf, let me edit, unhide last. The shelf is just centered, and when he's got everything assembled, right? He's got the legs and the stretchers assembled. He gets the shelf he sets the shelf on the stretchers, and then he makes sure that they're equal distance. It came to about 2 inches. The 2 inches from the inside of the leg to the shelf, 2 inches inside the leg to the shelf on all 4 legs, and he clamped that shelf to the legs, and then he flipped the whole thing over, and he ran screws right through the center. He already had it pre-drilled before he put the stretchers in all together, but he pre-drilled and counter something, but he ran a screw right through these 4 stretchers into the bottom of the table to secure it. The same thing with the top of the table with, bear with me just a second. When he put the top of the table on, he turned it upside down, set the table on the floor, turned it upside down, and then he just measured from the edge of the table to the inside on all 4 sides to make sure that it's equal, and then again ran screws these were already pre-drilled. You'll see the pre-drilled holes when you watch the video. They were already pre-drilled and everything. But again, on the ends here, he ran a block plane, a little handheld plane, and he did a little chamfer. You could do a chisel too if you're careful. Just be careful on the cross grain that you don't blow out or tear out or anything. But he did a little chamfer there, and it kind of gave it that, kind of green and green style and everything. If I were to, bear with me just a second here. So on all 4 sides, top, bottom, up, and down, and everything, they just did that little chamfer there on the ends to give it just kind of that, nice little cushion button look or whatever, the case may be. And you'll be able to see that in the in the video and everything. So chisel out those mortises. You're going to do a block plane, or you're going to put a chamfer on the ends there, and glue your parts together. And then those parts are going to get drilled right in the center for a screw to go in, to screw in from the bottom and into the tabletops and the shelf. The final part is the shelf. So we're going to create a new sheet, or the tabletop, sorry. And this is going to be the top. This is going to be a 24 by 24 inch top. 1 inch thick. Move that over to the top shelf and center that onto the board. And again, it's just a profile cut. You can decide if you want to put tabs or anything on it. You can put tabs on it, or you can double side tape it or what have you. This is 1 inch thick, cutting all the way through. Right? And then they did not use a block plane or anything. They just lightly sanded the edges to just break the edge, to get rid of that sharp edge. Just kind of slightly round it over with some sanding and everything on the edges of the shelf and the top and all. So this one was pretty straightforward. We had fillets. Make sure those fillets are hidden and everything with the joinery. We had our legs where we're going to do some corner chiseling. That's our hand tool techniques and all. Learn those and stuff. We're going to do some corner chisels. If you don't have a good set of chisels, run down to Harbor Freight. Get you a set, to start off with. They're pretty sharp tools and all. Later down the line, if you have some money or whatever, you can get a good set that really holds its edge and all really well. But hell, I can take a $20 set or $30 set, whatever, of Harbor Freight chisels, and I can throw them on a grinder and a sharpener, and I can get them, sharp. So there's videos on how to sharpen chisels and all that. It's not the greatest steel in the world, but still it works, right? And they also have corner chisels, right? You can order corner chisels, which actually they're shaped like a corner, and you just get them in place and you use a rubber mallet and tap them down and chisel out that whole corner in one shot. All right. I'm hoping that even though it was long, that some of you went to sleep and all, some of you stayed with me, some of you left. But Brooks, Martin, thanks for hanging out. Michael Murphy, thanks for bringing the class to my attention. There's a lot of other classes they have, especially the metal inlays. That's the next one I'm going to do. I don't know if that's going to be the next class or the one after, but I'm going to do the metal inlays. I like that, but some good things. But there were some things in there that were left to be desired as far as how to get it into Vectric, how to lay out the designs, where to put the fillets, and how to create the toolpaths. And hopefully this video, even though it was really long, served that purpose. That's what the purpose of this was, hey, how do we bring those files that they gave us into Vectric, and what needs to be changed, what do we lay out, and how do we lay them out? So hopefully that served its purpose exactly like it was supposed to. Great little projects. These are really nice tables, these arts and crafts tables. The round table, the Limbert Cafe inspired table. This is a really nice table and everything. I mean, it's 24 inches by 37 inches by 30 inches tall. It's a nice little table. And when it's all assembled and everything. And then the hall table, comes in at about 30 1/8 inches tall by an overall length of 36 inches. And the maximum width, the largest part of the footprint, you're looking at about 11.5 inches wide. Now, he explained in the video, which you'll notice here, that the legs are wide, right? 11.5, and the top is only 10 5/8. Now, he explained there's a reason for that. In his shop, his particular shop, he would like to have had a wider table for the hall table, a little bit wider, not much wider, but a little bit wider. But he didn't want to have to glue up a panel. He wanted it one solid continuous piece because it's a really, it's a nice hall table. He wanted one continuous piece, not a glue up, not an edge glue up or anything. And this piece of cherry that he used, or a piece of wood that he used, it was the biggest size piece that he had in his shop at the time. So he made it fit. He made the drawing fit what he had for that top. So that's why the legs, are 11.5. They're sprawled, but the top is only 10 5/8. You can go wider if you want and everything. Just make sure your joinery is positioned exactly the same. But you get these 3 PDFs with the files that are in the link in the description with that video for that class, that episode 14. You get these 3 PDFs and you get all of those vectors that we imported. What I will do is you have this class that showed some of the changes that we made. But what I'll do is I'll throw one in. I'm going to throw in the 3 files, the 3 VCarve Pro files, and the vector files for those that don't have 11.5 that I'm working in, the vector files, with the corrected vectors and all the fillets and stuff, right? I'll throw those files in there. They won't be tonight, but tomorrow that download will be ready as well. So you'll have the 3 Vectric VCarve CRV files plus the vector files if you don't have 11.5 and you can't open them. You'll have the vector files with all the fillets and the layout, the sheets and everything for your download too. So it'll give you kind of a comprehensive thing to work with. And I would love if any of you made these tables, make any one of these tables or whatever, I would love pictures. All right. So I'll in the chat, it's laney.shaughnessy@spindletv.com. I'll throw it in the chat right now, laney.shaughnessy@spindletv.com. I would love a little bit of show and tell. Show me the pictures if you do make those projects, if you make any of them, and I will share them in one of our classes, those photos of what pictures come in to me and stuff. Now, there's an error, there's a typo. Hold on a second. Give me just a second. Copy, remove, put that back in there. I had a space where I shouldn't have a space. laney.shaughnessy@spindletv.com. There we go. All right, yeah, put that orange thing in there. Anyway, but I hope you enjoyed tonight's class. Thank you for hanging out with me. I know it's a long one. It's 11 o'clock now. Thank you, thank you, thank you. I appreciate each and every one of you. And if you did have questions, I'll go through the chat and I'll read the questions and I'll put them in the comment section of this video, this class video, because I didn't have time to get all this done and answer any questions you might have had. So I'll go through and see if I missed any questions. I'll put the answers in the chat. And until next time, you folks have a yeah, that's fine, Mark. Simple Design at A Simple Design of Ocala, a Simple Design of Ocala @gmail.com. If you still got that old email, A Simple Design of Ocala @gmail.com, that'll work too. All right, everybody. Y'all have a great one. Michael Murphy, thanks for bringing this to my attention, this class, and hopefully you got out of it what you were hoping to get out of it. And thanks for hanging out with me this late, guys. It's been a long night. Have a great night. See ya.